Today we're doing a crash course of the A+ 220, 1201, and 1202. So what we've done is taken every single acronym from both exams and gone through them slide by slide to explain every single one of them. Consider this a crash course to review right before you take your exam. And of course we have the full-length in-depth videos for both exams as well, which are roughly 10-ish hours each. So enjoy this accelerated crash course that is significantly less time than the full 20 hours for both full exam courses. Authentication, authorization, and accounting. Authentication is the process of verifying the identity of a user or device. Authorization is the determination of what actions or resources a user or device can access after authentication. Accounting is the tracking and logging of user activities such as resource usage and access attempts. AAA protocol often implemented using protocols like Radius or TACX+ to manage authentication, authorization, and accounting. The AAA framework helps ensure that only authorized users can access specific resources and that all actions are logged for auditing purposes. An access control list, or ACL, is a set of rules used to define permissions for users or devices on a network or system. ACLs specify which users or devices are allowed or denied access to specific resources based on IP addresses, subnets, or user roles. There are two primary types of ACLs: standard ACLs, which filter based on source IP, and extended ACLs, which provide more detailed control, filtering by source IP, destination IP, and protocol. ACLs are commonly used in routers, firewalls, and network devices to control incoming and outgoing traffic. They provide a mechanism for controlling network traffic, preventing unauthorized access, and protecting sensitive information. An automatic document feeder, or ADF, is a device that automatically feeds multiple pages into a scanner or copier without manual intervention. ADFs allow for efficient scanning, copying, or faxing of multiple page documents, eliminating the need to manually insert each page. There are two types of ADFs: simple ADFs, which can feed one page at a time, and duplex ADFs, which can scan both sides of a page automatically. They enhance productivity by saving time in high-volume document handling, providing convenience and reducing human error. ADFs are commonly found in multifunction printers, copiers, and scanners in both home and office environments. AES, or Advanced Encryption Standard, is a symmetric key encryption algorithm used to secure data by transforming it into an unreadable format without the correct decryption key. AES supports three key sizes: 128-bit, 192-bit, and 256-bit, with larger key sizes offering stronger encryption. It operates on fixed-size blocks. For example, the 128-bit key size uses 128 bits and uses multiple rounds of transformation to encrypt or decrypt the data. AES is widely regarded as highly secure and is used globally for protecting sensitive data in various applications, including government, banking, and telecommunications. AES has replaced older encryption algorithms like DES due to its high security and efficiency. Advanced Micro Devices, or AMD, is a leading global semiconductor company specializing in high-performance computing, graphics, and visualization technologies. AMD is known for its processors, graphics processing units, and system-on-chip products, primarily serving markets such as personal computing, gaming, and data centers. AMD's Ryzen, EPYC, and Radeon product lines are some of its most notable innovations, competing with Intel and NVIDIA in the CPU and GPU markets. AMD has gained significant market share in recent years, challenging industry giants like Intel and NVIDIA with its performance and efficiency advancements, particularly in gaming and data center markets. AMD focuses on delivering cutting-edge, energy-efficient products that provide exceptional value to consumers, businesses, and enterprises. An access point, or AP, is a networking device that allows wireless devices to connect to a wired network using Wi-Fi. APs act as a bridge between wired and wireless networks, enabling devices like laptops, smartphones, and tablets to access the internet and local resources. There are two main types of access points: standalone or dedicated devices, and controller-based, which are managed by a central controller for larger networks. Access points can implement various security protocols, such as WPA3, to protect wireless networks from unauthorized access. APs are commonly used in home networks, businesses, and public spaces to provide wireless internet access. Apple File System, or APFS, is a modern file system developed by Apple for use in macOS, iOS, watchOS, and tvOS. APFS includes features like space sharing, fast file cloning, strong encryption, and crash protection to enhance performance and security. APFS supports both solid-state drives, or SSDs, and traditional hard drives, or HDDs, but it's optimized for SSDs. APFS uses copy-on-write mechanism that ensures data integrity by avoiding data corruption during unexpected power loss or system crashes. It offers built-in encryption with support for multiple keys, allowing for better security of sensitive data. APIPA, or Automatic Private IP Addressing, is a feature in Windows operating systems that automatically assigns a private IP address to a device when a DHCP server is unavailable. APIPA assigns IP addresses in the 169.254.0.1 to 169.254.255.254 range, which are reserved for local network communication. When a device cannot obtain an IP address from a DHCP server, it will use APIPA to assign itself an address within this range, enabling limited network communication. Devices using APIPA can only communicate with others on the same local network segment, but they cannot access the internet or other remote networks. APIPA is often a sign of a problem with the DHCP server or network configuration, and it can be resolved by checking the DHCP server or manually assigning an IP address. An Advanced RISC Machine, or ARM, is a type of reduced instruction set computer, or RISC architecture used in many modern processors, particularly in mobile devices. ARM processors are known for their energy efficiency and high performance, making them ideal for battery-powered devices like smartphones and tablets. ARM processors utilize a simplified set of instructions, allowing for faster execution of operations and lower power consumption compared to complex instruction set computers, or CISC. ARM is widely used in consumer electronics, embedded systems, and IoT devices due to its low power requirements and efficient processing capabilities. ARM architecture is supported by a large ecosystem of developers, software tools, and applications, contributing to its widespread adoption in various industries. Advanced Technology Extended, or ATX, is a standard motherboard form factor commonly used in desktop computers. The standard ATX motherboard measures 12 by 9.6 inches, providing ample space for components and expansion slots. ATX motherboards use a 24-pin power connector with optional 4 or 8-pin for additional CPU power to connect to the power supply. ATX motherboards support multiple expansion slots like PCI or PCIe, RAM slots, and a variety of I/O ports, making them ideal for gaming, workstations, and general desktop use. The ATX standard allows for easy upgrades, excellent airflow, and flexibility in component choice, making it a popular choice for custom-built PCs. An Acceptable Use Policy, or AUP, is a set of rules and guidelines that govern the appropriate use of an organization's network, systems, and resources. The primary goal of an AUP is to protect the organization from legal issues, security risks, and misuse of resources by ensuring that users understand what constitutes acceptable and unacceptable behavior. A typical acceptable use policy includes rules regarding internet use, email usage, downloading files, accessing sensitive information, and the installation of software. Violations of the AUP can result in disciplinary action, ranging from warnings to termination, depending on the severity of the breach. A well-defined acceptable use policy is essential for maintaining security, compliance, and ethical behavior within an organization's digital environment. Business Email Compromise, or BEC, is a type of cybercrime where attackers use fraudulent emails to impersonate executives or employees to steal money or sensitive information. BEC attacks often involve social engineering tactics such as phishing, spear phishing, or spoofing to manipulate individuals into transferring funds or sharing confidential data. The most common targets of BEC are businesses, particularly those with financial transactions or international dealings, including executives and employees in accounting or finance roles. BEC can lead to significant financial loss, reputational damage, and legal issues, especially when sensitive data or money is stolen. To prevent BEC, businesses should implement multi-factor authentication, employee training, and robust email filtering systems to detect and block suspicious emails. The basic input-output system, or BIOS, is firmware stored on a motherboard that initializes hardware and provides an interface between the operating system and hardware components. BIOS is responsible for the power-on self-test, or POST, which checks the hardware components before the operating system starts. It then loads the bootloader from the storage device to start the operating system. BIOS allows users to configure hardware settings such as boot order, system clock, and CPU settings through a BIOS setup menu. Traditional BIOS is being replaced by Unified Extensible Firmware Interface, or UEFI, which provides more advanced features like secure boot and support for larger storage drives. BIOS also plays a role in system security with features like BIOS passwords and secure boot to prevent unauthorized access. The Bayonet Neil-Conselman, or BNC connector, is a type of coaxial cable connector used for transmitting signals in a variety of electronic applications. BNC connectors feature a locking mechanism with a bayonet-style coupling, ensuring a secure connection that can be easily attached or removed by twisting the connector. BNC connectors are commonly used in video and audio equipment, networking, and telecommunications, particularly for analog signals and CCTV systems. There are different types of BNC connectors, including those for standard coaxial cables, BNC male and female, with various impedance levels, typically 50 ohms or 75 ohms. BNC connectors provide reliable, stable connections and are favored for their durability and ease of use, even in high-frequency applications. The blue screen of death, or BSOD, is a critical error screen in Windows operating systems that appears when the system encounters a serious issue that prevents it from continuing to operate. Common causes of BSOD include hardware failures, corrupted system files, incompatible drivers, or issues with software such as memory leaks or viruses. BSOD displays specific error codes or messages that can help diagnose the problem, such as stop code or system service exception. To resolve a BSOD, users can check recent hardware or software changes, run system diagnostics, or perform a system restore or reinstall to fix corrupted files. Keeping drivers up to date, running regular system scans, and ensuring proper hardware maintenance can help prevent BSOD errors. Bring Your Own Device, or BYOD, refers to a policy where employees are allowed to use their personal devices, such as smartphones, tablets, and laptops for work purposes. BYOD can lead to increased productivity, cost savings, and employee satisfaction as individuals use familiar devices and have more flexibility. BYOD introduces security risks, including data breaches, loss of control over devices, and challenges in managing sensitive corporate data on personal devices. Companies often implement mobile device management solutions, or MDM, to secure and manage personal devices, enforcing policies for data encryption, remote wiping, and access controls. To mitigate risks, organizations should establish clear BYOD policies that define acceptable device usage, security requirements, and privacy guidelines. Calling card authorization refers to a method used to verify the identity of a user by utilizing a calling card, which stores specific authentication information. Commonly used in telecommunications, this method requires the user to input a calling card number or PIN to authenticate their identity before gaining access to certain services or systems. The calling card method is typically combined with other security measures, such as encryption or user-specific data, to ensure the integrity of the authentication process. CCA is often used in long-distance services, toll-free number services, and some legacy systems where users need to authenticate before initiating calls or using certain features. While secure in certain contexts, the reliance on physical cards can be vulnerable to theft or loss, requiring additional protections to ensure secure access. Common Internet File System, or CIFS, is a network file sharing protocol used to enable file access and sharing between computers over a network, commonly used in Windows environments. CIFS allows applicants to read and write to files, request services from server programs, and access files over a network. CIFS is based on the Server Message Block, or SMB protocol, facilitating communication between computers, printers, and other devices in a network. CIFS is commonly used in enterprise environments to share files, printers, and other resources over local area networks and over the internet. While CIFS supports various authentication methods, it has been replaced by more secure versions of SMB, such as SMB 2.0 and SMB 3.0, which offer improved security features. A Configuration Management Database, or CMDB, is a repository used by organizations to store information about their IT assets, including hardware, software, and network configurations. CMDB helps track and manage the relationships between various components of an IT infrastructure, ensuring that all configuration items, or CIs, are documented and up to date. By providing a centralized view of the IT environment, CMDB enhances decision-making, streamlines troubleshooting, and supports change management processes. CMDB integrates with IT service management tools, or ITSM tools, to provide accurate data for incident management, problem resolution, and other IT processes. To remain effective, CMDBs require regular updates and audits to ensure the accuracy of the configuration data, which can be complex in dynamic IT environments. A canonical name, or CNAME, is a type of DNS, or Domain Name System record, that maps an alias or subdomain to the canonical or true domain name. CNAME records allow multiple domain names to point to a single IP address or web server, simplifying DNS management. CNAME records are often used for pointing subdomains like www, mail, or blog to the main domain, enabling consistency across different services. They make it easier to manage changes in domain names by allowing administrators to update the canonical domain instead of each individual alias. CNAME records cannot be used for the root domain, for example, example.com, and should be used carefully to avoid potential DNS lookup issues or loops. The Central Processing Unit, or CPU, is the primary component of a computer that performs most of the processing inside a system, executing instructions from programs and applications. The CPU handles tasks such as arithmetic operations, logical operations, data manipulation, and control of other components within the system. A typical CPU consists of the Arithmetic Logic Unit, or ALU, Control Unit, or CU, and various registers for storing data and instructions temporarily. CPU performance is often measured by clock speed, or gigahertz, which indicates how many cycles the CPU can execute per second. Higher clock speeds typically result in better performance. Modern CPUs often feature multiple cores, allowing them to handle multiple tasks simultaneously, improving performance for multitasking and complex operations. DB9 is a type of serial connector used for data transmission, characterized by its 9-pin configuration and commonly used for RS-232 serial communication. It stands for Serial Communications D-Shell Connector 9-pin. The DB9 connector features 9 pins arranged in 2 rows, typically used for transmitting data, receiving data, and providing ground connections. DB9 connectors are often found in older computer systems, networking devices, and serial peripherals, such as modems, mice, and printers. While DB9 connectors were once widely used for communication between computers and peripheral devices, they have been largely replaced by USB and other modern interfaces. The DB9 connector is simple, durable, and provides reliable data transfer for low-speed serial communication over short distances. A distributed denial of service, or DDoS attack, is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming it with a flood of internet traffic from multiple sources. DDoS attacks often involve botnets, where compromised devices, often called zombies, are used to generate massive traffic, making it difficult to trace and block the attack. The primary goal of a DDoS attack is to make a service unavailable to its intended users, causing downtime, service disruption, or loss of revenue. Common DDoS attack types include volumetric attacks, protocol attacks, and application layer attacks, each targeting different layers of the network or application stack. Defending against DDoS attacks involves techniques like traffic filtering, rate limiting, and using DDoS protection services to absorb large amounts of malicious traffic. Double data rate, or DDR, refers to a type of memory technology that allows data to be transferred twice per clock cycle. Double data rate, or DDR, refers to a type of memory technology that allows data to be transferred twice per clock cycle, improving data transfer rates compared to previous memory technologies. DDR has evolved through several generations, including DDR1, 2, 3, and 4, with each offering improvements in speed, efficiency, and power consumption. DDR memory transfers data on both the rising and falling edges of the clock signal, doubling the effective data transfer rate without increasing the clock frequency. DDR is commonly used in computer RAM or random access memory for desktops, laptops, and servers, as well as in gaming consoles and other high-performance devices. DDR memory's higher bandwidth and lower latency contribute to improved system performance, especially in applications that require significant memory throughput, such as gaming, video editing, and scientific computations. Dynamic Host Configuration Protocol, or DHCP, is a network protocol used to automatically assign IP addresses and other network configuration settings to devices on a network. DHCP allows devices to join a network without requiring manual configuration, ensuring that each device receives a unique IP address and appropriate network settings like subnet mask and default gateway. When a device connects to the network, it sends a DHCP request, and the DHCP server responds with an IP address lease, which is valid for a certain period. DHCP simplifies network administration by reducing the need for manual IP address assignment and minimizing the risk of IP address conflicts. While DHCP simplifies network management, it can also introduce security risks if improperly configured, such as unauthorized devices obtaining network access through rogue DHCP servers. A dual inline memory module, or DIMM, is a type of memory module used in computers to hold RAM or random access memory chips, providing the system with fast temporary data storage. DIMMs have separate electrical contacts on both sides of the module, allowing for higher bandwidth and better performance compared to older SIMMs, or single inline memory modules. DIMMs come in various configurations such as DDR, DDR2, DDR3, and DDR4, with each offering improvements in speed, power efficiency, and data transfer rates. DIMMs typically support higher capacities and are used in desktops, servers, and high-performance workstations to handle demanding applications. The increased number of pins and improved signal integrity make DIMMs more reliable and faster at transferring data compared to previous memory module designs. Domain Keys Identified Mail, or DKIM, is an email authentication method that allows the sender to associate a domain name with an email message, providing a way to verify the sender's identity and ensure the message's integrity. DKIM uses cryptographic keys to sign outgoing email messages, which can be verified by recipients using a public key stored in the DNS, or domain name system, of the sender's domain. DKIM helps prevent email spoofing by ensuring that the email content has not been altered in transit and that it's indeed from the claimed sender. DKIM is commonly used in conjunction with other email authentication methods such as SPF, or Sender Policy Framework, and DMARC, or Domain-Based Message Authentication, Reporting, and Conformance, to enhance email security and reduce phishing attempts. Setting up DKIM requires configuring DNS records with public keys and signing outgoing emails with private keys, which typically involves integration with email servers or services. Data loss prevention, or DLP, refers to strategies, policies, and technologies used to prevent unauthorized access, use, or transmission of sensitive data outside an organization's network. DLP solutions can be classified into network-based, endpoint-based, and cloud-based, each focusing on different aspects of data protection, such as preventing data leakage from devices, networks, or cloud services. DLP technologies monitor and control data movement across devices, email systems, and networks, detecting and blocking unauthorized actions, such as copying sensitive information to external drives or sending it via unapproved channels. DLP is commonly used in industries like healthcare, finance, and government, where the protection of sensitive data, for example personal, financial, or medical records, is critical to regulatory compliance and preventing breaches. By reducing the risk of data breaches and ensuring compliance with privacy laws, DLP helps organizations safeguard valuable data and maintain trust with customers. DMARC is an email authentication protocol that builds on SPF, or Sender Policy Framework, and DKIM, or Domain Keys Identified Mail, to detect and prevent email spoofing and phishing attacks. DMARC stands for Domain-Based Message Authentication, Reporting, and Conformance. DMARC allows domain owners to specify how email receivers should handle unauthenticated emails, such as quarantining or rejecting them, and provides a reporting mechanism for domain owners to receive feedback on email authentication issues. DMARC helps protect against domain impersonation by ensuring that only authorized senders can send emails on behalf of a domain, reducing the likelihood of phishing and spam. DMARC includes a reporting feature that provides feedback on email authentication results, helping administrators monitor the effectiveness of their email security setup and identify potential threats. Setting up DMARC involves publishing a DMARC policy in the domain's DNS records, defining how to handle suspicious emails, and ensuring that both SPF and DKIM are properly configured. The Domain Name System, or DNS, is a hierarchical and decentralized naming system used to translate human-readable domain names, like www.example.com, into IP addresses. DNS acts like a phone book for the internet, enabling users to access websites and online services by using easy-to-remember domain names instead of numeric IP addresses. DNS consists of several key components, including DNS servers, which store domain name information, domain name records such as A, MX, and CNAME records, and resolver clients, which request the information from DNS servers. Common DNS record types include A records, MX records, and CNAME records, each serving different purposes in routing traffic. DNS security features like DNSSEC or DNS security extensions help prevent attacks such as DNS spoofing, which can redirect users to malicious websites. A denial of service or DOS attack is a malicious attempt to disrupt the normal traffic of a network, service, or system, making it unavailable to users. DOS attacks typically work by overwhelming a server or network with excessive requests, causing it to crash or become slow, preventing legitimate users from accessing the service. Common types include flooding attacks, like UDP or SYN floods, and resource exhaustion attacks, which aim to overload the system's resources, such as CPU or memory. A more advanced form, a distributed denial of service or DDoS attack, involves multiple systems working together to launch a larger, more difficult to mitigate attack. Defending against DOS attacks involves using firewalls, intrusion detection systems, rate limiting, and DDoS protection services to filter and block malicious traffic. Digital rights management, or DRM, refers to a set of technologies used to control the use, distribution, and access to digital content, such as music, movies, ebooks, and software. DRM is designed to prevent unauthorized copying, sharing, and distribution of copyrighted digital media, ensuring that creators and publishers retain control over their content. DRM techniques include encryption, watermarking, and license keys, which limit how and where content can be used or shared. While DRM helps protect intellectual property, it has faced criticism for restricting fair use and causing compatibility issues, as some DRM systems may limit access to purchased content. DRM is commonly used in industries such as entertainment, publishing, and software development to protect content from piracy and unauthorized distribution. Digital Subscriber Line, or DSL, is a high-speed internet connection technology that uses existing telephone lines to deliver broadband internet service. Common types of DSL include asymmetric DSL, or ADSL, which provides faster download speeds than upload speeds, and symmetric DSL, or SDSL, which offers equal speeds for both downloading and uploading. DSL operates by splitting the telephone line into separate channels for voice and data, allowing both to be used simultaneously without interference. DSL speeds can vary depending on the type of DSL, the distance from the service provider's central office, and the quality of the phone lines, with typical speeds ranging from several megabits per second to tens of megabits per second. DSL provides a reliable internet connection with the advantage of using existing telephone lines, eliminating the need for new infrastructure, and is often more affordable than fiber optic services. Digital Visual Interface, or DVI, is a video display interface used to connect computers to monitors, providing a digital connection for higher quality video output. There are three main types of DVI connectors: DVI-D, digital only, DVI-A, analog only, and DVI-I, integrated, which supports both digital and analog signals. DVI transmits uncompressed digital video signals, resulting in better image quality compared to analog connectors, making it ideal for high-definition displays. DVI is often found in older monitors and graphics cards, but is gradually being replaced by newer standards like HDMI and DisplayPort, which offer additional features like audio transmission. DVI supports higher resolutions and refresh rates, making it suitable for gaming, professional video editing, and high-definition media applications. Error-correcting code, or ECC, is a type of computer memory that can detect and correct common types of data corruption, ensuring the integrity of stored data. ECC memory adds extra bits to each data byte, allowing it to detect and correct single-bit errors automatically and detect but not correct double-bit errors. ECC is commonly used in servers, workstations, and other systems where data integrity is critical, such as financial systems or scientific computing. By preventing data corruption and system crashes, ECC memory enhances system reliability and minimizes downtime, especially in environments with large volumes of critical data. ECC memory is typically more expensive and slower than non-ECC memory due to the additional processing required for error detection and correction. Endpoint detection and response, or EDR, refers to a set of security tools and practices used to monitor, detect, and respond to threats on endpoint devices such as laptops, desktops, and mobile devices. EDR solutions provide real-time monitoring of endpoints, detecting suspicious activity, blocking potential threats, and gathering data for forensic analysis and incident response. EDR systems typically include features like malware detection, behavior analysis, threat hunting, and automated incident response to quickly mitigate security risks. EDR enhances security by providing visibility into endpoint activity, enabling faster identification and response to threats, thus reducing the risk of data breaches or system compromises. EDR solutions are often integrated with other security technologies, such as Security Information and Event Management Systems, or SIEM, to provide a comprehensive security posture. The Encrypting File System, or EFS, is a feature in Microsoft Windows that allows users to encrypt individual files or folders to protect sensitive data from unauthorized access. EFS uses symmetric encryption to encrypt data, ensuring that only authorized users with the proper encryption key can access the protected files or folders. EFS is integrated into the Windows operating system, making it easy to use for file and folder encryption without the need for third-party software. EFS provides an added layer of security, protecting files even if the device is stolen or accessed by unauthorized individuals. EFS encryption is user-specific, meaning that if a user loses their encryption key or certificate, they may not be able to recover the encrypted data. End of life, or EOL, refers to the point at which a product such as hardware or software is no longer supported or updated by its manufacturer or developer. Once a product reaches end of life, the manufacturer stops releasing updates, patches, and security fixes, which can leave systems vulnerable to security threats. Using end-of-life products exposes organizations to potential cybersecurity risks, as unpatched vulnerabilities are no longer addressed by the vendor. EOL products should be replaced with newer, supported versions to ensure continued functionality, security, and compatibility with modern systems. IT teams must plan for EOL products by tracking vendor lifecycle dates and budgeting for upgrades to avoid service disruptions. eSATA, or External Serial ATA, is an interface standard used for connecting external storage devices, such as hard drives and solid-state drives, to a computer using the Serial ATA or SATA protocol. eSATA provides high-speed data transfer rates, typically faster than USB 2.0 or FireWire, making it ideal for high-performance external storage solutions. eSATA is compatible with many desktop and laptop systems, but requires specific eSATA ports or adapters, as it is not supported by traditional USB ports. eSATA offers faster data transfer rates and lower latency than USB or FireWire, particularly for applications requiring large file transfers, like video editing or backups. While eSATA is faster than other external interfaces, it lacks power delivery, meaning an external power source is required for most eSATA devices. Electrostatic discharge, or ESD, is the sudden flow of electricity between two objects with different electrical potentials, often caused by direct contact or an electric field. ESD can damage sensitive electronic components, such as computer chips or circuit boards, leading to performance degradation or complete failure. Common causes of ESD include walking on carpet, touching metal objects, or handling electronics without proper grounding. To prevent ESD, technicians use tools like anti-static wrist straps, mats, and grounding devices to safely dissipate static electricity before working with sensitive components. Proper handling in ESD-safe work environments are essential to avoid damage to electronic components during repairs, upgrades, or installations. An end-user license agreement, or EULA, is a legal contract between the software provider and the end user outlining the terms and conditions for using the software. EULAs specify the rights, limitations, and responsibilities of the user, including licensing terms, restrictions on software usage, and permissions for updates or modifications. Typical components of a EULA include the scope of the license, restrictions on redistribution, liability limitations, and privacy policy details. Users must agree to the EULA terms before installing or using this software, often done by clicking on an I agree button during installation. EULAs are important for protecting intellectual property, ensuring that users understand and comply with usage rights, and limiting the software provider's liability. exFAT, or Extended File Allocation Table, is a file system designed for flash drives, SD cards, and other portable storage devices, offering a balance between performance and file size support. exFAT is compatible with both Windows and Mac OS, making an ideal choice for cross-platform file sharing, unlike older file systems like FAT32. exFAT supports larger file sizes up to 16 exabytes and volumes up to 128 petabytes, making it suitable for handling high-definition video files and large data sets. exFAT offers faster read-write speeds compared to FAT32, especially with large files, and is optimized for flash memory devices. exFAT is commonly used in external storage devices like USB drives, SD cards, and external hard drives, particularly for use in digital cameras, gaming consoles, and media players. The File Allocation Table, or FAT, is a file system architecture used for managing and organizing files on storage devices like hard drives, USB drives, and SD cards. There are several versions of FAT file system, including FAT12, FAT16, and FAT32, each with varying limits on file and volume size. FAT organizes data into clusters, which are groups of sectors on a disk, and maintains a table that tracks the allocation of each cluster, helping the system locate and access files efficiently. FAT is widely supported across multiple operating systems, including Windows, Mac OS, and Linux, making it ideal for portable storage devices and file sharing. The FAT file system has limitations, such as lower file and volume size support compared to newer file systems like NTFS or exFAT, particularly for large file sizes and modern storage requirements. Facial recognition technology, or FRT, uses biometric software to identify or verify a person by analyzing and comparing facial features in images or videos. The system captures facial data, creates a unique facial template, and then matches it against the database of known faces for identification or verification. Facial recognition is used in various fields, such as security for surveillance and access control, mobile devices for unlocking phones, and law enforcement for identifying suspects. It offers a fast, contactless, and relatively secure method of identification, improving user convenience and security in many applications. While effective, facial recognition raises privacy and ethical concerns, particularly regarding surveillance, data security, and the potential for misuse or unauthorized tracking. File Transfer Protocol, or FTP, is a standard network protocol used to transfer files between a client and a server over a TCP/IP network. FTP allows users to upload, download, and manage files on a remote server, typically using a client application or command line interface. FTP operates in two modes: active mode, where the server opens a connection to the client, and passive mode, where the client initiates the connection to the server. Standard FTP transmits data, including credentials in plaintext, which can expose sensitive information. Secure versions such as FTPS, or FTP Secure, and SFTP, or SSH File Transfer Protocol, encrypt the data to provide enhanced security. FTP is commonly used for website management, transferring large files, and synchronizing files between remote systems or backups. The grandfather-father-son, or GFS, backup strategy is a data backup rotation method that uses three distinct backup sets: daily, son; weekly, father; and monthly, grandfather. The strategy involves rotating these backup sets over time, where daily backups are overwritten by new ones, weekly backups are replaced less frequently, and monthly backups are archived for long-term storage. GFS helps balance the need for regular backups with the retention of historical data, ensuring that important files can be restored from both recent and older backups. The Sun backups are typically overwritten every day, The father backups are kept for a week, and the grandfather backups are stored for a longer period, like a month or a year. This strategy is widely used in business environments to manage backup data efficiently while ensuring critical data is protected and accessible for recovery. The Global Positioning System, or GPS, is a satellite-based navigation system that provides location and time information to users anywhere on Earth. GPS operates using a constellation of at least 24 satellites orbiting Earth, ground stations to monitor the satellites, and GPS receivers to calculate location and time data. GPS receivers calculate their position by triangulating signals from at least 3 or 4 satellites, allowing for accurate positioning within a few meters. GPS is used in various fields, including navigation for vehicles, mobile devices, aviation, military, and geospatial data collection. GPS accuracy can be affected by environmental factors like buildings, trees, or atmospheric conditions, but modern technologies like differential GPS or DGPS can improve precision. The GUID partition table, or GPT, is a partitioning scheme used to define the structure of partitions on a storage device, such as hard drives and SSDs, based on a globally unique identifier, or GUID. GPT offers several advantages over the older master boot record, or MBR, partitioning scheme, including support for larger disk sizes over 2 terabytes, more partitions up to 128, and enhanced data integrity with CRC32 checksums. GPT is commonly used with modern operating systems and is required for booting from UEFI, or Unified Extensible Firmware Interface systems, replacing the older BIOS-based boot process. GPT partitions are identified by GUIDs, which are unique identifiers that ensure each partition can be easily recognized and accessed, even across different devices and systems. GPT is used for high-capacity storage devices, including those in servers, desktops, and laptops, and is the default partitioning scheme for newer systems running Windows, Mac OS, and Linux. A globally unique identifier, or GUID, or GUID, is a 128-bit value used to uniquely identify objects or entities across systems, ensuring no two GUIDs are the same. GUIDs are typically represented by a string of hexadecimal characters, often formatted as a series of 5 groups of numbers separated by hyphens. GUIDs are commonly used in software development, database systems, and network protocols to uniquely identify resources such as records, files, and devices across different systems or applications. The primary benefit of a GUID is its guarantee of uniqueness, allowing distributed systems to generate identifiers without risk of duplication. GUIDs are widely used in Microsoft technologies such as COM objects in Active Directory and various other industries to uniquely identify objects and components in databases and systems. A hard disk drive, or HDD, is a data storage device that uses mechanical parts, including rotating disks or platters, and read-write heads to store and retrieve digital information. HDDs store data magnetically on spinning disks, with the read-write heads moving across the surface of the platters to access data. HDDs offer large storage capacities, typically ranging from several hundred gigabytes to multiple terabytes, and their data transfer speeds are measured in revolutions per minute, or RPM, with common speeds being 5400 RPM and 7200 RPM. HDDs are generally more affordable than solid-state drives for the same storage capacity, making them a popular choice for bulk storage needs. While offering large storage at a lower cost, HDDs are slower, more prone to mechanical failure, and consume more power compared to SSDs. HDMI, or High Definition Multimedia Interface, is a digital interface used for transmitting high-quality audio and video signals between devices such as computers, TVs, monitors, and gaming consoles. HDMI supports both uncompressed video such as 4K or 1080p and multi-channel audio, offering a single-cable solution for high-definition content transmission. HDMI has evolved through multiple versions, including HDMI 1.4, 2.0, and 2.1, each offering higher resolutions, refresh rates, and new features such as enhanced audio return channel, or eARC, and support for higher bandwidth. HDMI is commonly used in home entertainment systems, professional video setups, and personal computing to connect devices like HDTVs, projectors, soundbars, and computers. HDMI provides a simplified, high-quality connection with support for both video and audio over a single cable, making it easy to set up devices without the need for multiple cables. A hardware security module, or HSM, is a physical device used to manage and safeguard digital keys for strong authentication and encryption, ensuring the secure processing of sensitive information. HSMs are used to generate, store, and manage cryptographic keys, offering high levels of security for encryption operations such as data encryption, digital signatures, and secure communications. HSMs are designed to be tamper-resistant, with features that protect against physical and logical attacks, providing an additional layer of security for critical data. HSMs are commonly used in industries like banking, government, and healthcare for securing sensitive data such as payment transactions, digital certificates, and personal identification information. HSMs are often used to comply with security standards and regulations such as PCI DSS, or Payment Card Industry Data Security Standard, and FIPS, or Federal Information Processing Standards. Hypertext Transfer Protocol, or HTTP, is a protocol used for transmitting hypertext requests and information on the World Wide Web, facilitating communication between web browsers and servers. HTTP defines how messages are formatted and transmitted and how web servers and browsers respond to various commands, allowing users to access web pages and resources. HTTP is a stateless protocol, meaning each request made by a client to a server is independent without retaining information about previous interactions. HTTPS, or Hypertext Transfer Protocol Secure, is an encrypted version of HTTP that uses SSL/TLS protocols to protect data during transmission, ensuring secure communication between the client and server. HTTP is the foundation of data exchange on the web, used for accessing websites, retrieving resources, and enabling web-based applications. HTTPS, or Hypertext Transfer Protocol Secure, is an extension of HTTP that uses encryption protocols like SSL/TLS to secure communications between a web browser and a server. HTTPS encrypts data exchange between the client and server, ensuring the privacy and integrity of sensitive information such as login credentials, payment details, and personal data. HTTPS works by establishing a secure connection using a public and private key pair, ensuring that data cannot be intercepted or tampered with during transmission. HTTPS also provides authentication, verifying the identity of the web server through SSL/TLS certificates, helping to protect users from phishing and man-in-the-middle attacks. HTTPS is essential for secure online transactions, banking, e-commerce websites, and any site that handles sensitive information. Infrastructure as a Service, or IaaS, is a cloud computing model that provides virtualized computing resources over the internet, such as virtual machines, storage, and networking. IaaS allows businesses to rent computing infrastructure on a pay-as-you-go basis, avoiding the need to purchase and maintain physical hardware. Common IaaS components include virtual machines, storage, networking, load balancers, and firewalls, which are all scalable based on user needs. IaaS offers flexibility, scalability, and cost efficiency, allowing businesses to scale their infrastructure up or down based on demand without investing in expensive physical hardware. IaaS is commonly used for hosting websites, running applications, development and testing environments, and disaster recovery solutions. Identity and Access Management, or IAM, refers to a framework of policies, technologies, and tools used to manage and secure user identities and their access to systems and resources within an organization. Key components of IAM include authentication, or verifying user identity, authorization, or granting access to resources, and auditing, tracking, and logging user activities. IAM systems use various methods for authentication, such as passwords, biometrics, multi-factor authentication, and single sign-on to ensure secure access. IAM improves security by enforcing access controls, reducing the risk of unauthorized access, and ensuring compliance with security regulations and standards. IAM is used across various industries to manage user roles, permissions, and security policies for applications, databases, networks, and cloud resources. Internet Message Access Protocol, or IMAP, is an email protocol that allows email clients to access and manage messages stored on a mail server, offering a more flexible solution compared to POP3. IMAP enables users to view, organize, and synchronize their email across multiple devices by keeping messages on the server rather than downloading them. IMAP supports folder management, message synchronization, and real-time updates, making it ideal for users who access their email from different devices, such as smartphones, tablets, and computers. IMAP supports secure encryption methods, such as SSL/TLS, to ensure that email data is transmitted securely between the client and the server. IMAP is commonly used by businesses and individuals who need to manage their email on multiple devices while keeping messages stored on the server. Input-output operations per second, or IOPS, is a performance measurement used to quantify the number of read and write operations a storage device, like a hard drive or solid-state drive, can perform in 1 second. IOPS is a key metric for evaluating storage device performance, especially in environments where frequent data access is required, such as databases or high-traffic websites. Several factors impact IOPS, including the type of storage device, HDD versus SSD, the type of data being read or written, sequential versus random, and the device's hardware specifications. IOPS is crucial for understanding the responsiveness of a storage system, especially in workloads that involve large numbers of small, random read-write operations, which are common in business applications and virtualized environments. IOPS is used to assess the performance of storage solutions in high-demand systems such as enterprise servers, cloud infrastructure, and data centers. The Internet of Things, or IoT, refers to the network of physical devices, vehicles, appliances, and other objects that are embedded with sensors, software, and connectivity to collect and exchange data. IoT devices communicate over the internet or local networks, allowing them to send and receive data, which can be used for automation, monitoring, and decision-making. IoT is used in various fields, including smart homes, healthcare, industrial automation, and agriculture. As IoT devices often collect sensitive data, they can pose security risks if not properly secured, making encryption and access control essential to protect privacy. The IoT market is expected to continue expanding, with billions of connected devices anticipated in the coming years, driving innovation in automation, data analytics, and smart infrastructure. Internet Protocol, or IP, is a set of rules that govern how data is sent and received over the internet and local networks, ensuring proper routing and addressing of data packets. There are two primary versions of IP: IPv4, or Internet Protocol version 4, and IPv6, or Internet Protocol version 6. IPv4 uses 32-bit addresses, while IPv6 uses 128-bit addresses, allowing for a vastly larger address space. IP is responsible for addressing and routing packets of data between devices on different networks, ensuring that data reaches the correct destination. IP addresses are unique identifiers assigned to devices on a network. IPv4 addresses are expressed in 4 decimal numbers, while IPv6 addresses are longer and written in hexadecimal. IP is a fundamental protocol in the TCP/IP suite, working in conjunction with other protocols such as TCP, or Transmission Control Protocol, and UDP, or User Datagram Protocol, to enable reliable communication over networks. In-plane switching, or IPS, is a type of LCD, or liquid crystal display technology used for improving color accuracy and viewing angles in display screens. Unlike traditional LCDs, IPS displays offer wider viewing angles, allowing users to view the screen from various positions without significant color distortion or brightness loss. IPS technology delivers superior color consistency and accuracy, making it ideal for applications requiring precise color representation, such as graphic design and video editing. IPS panels tend to have slower response times compared to other technologies like TN or twisted pneumatic, but recent advancements have reduced this gap, improving performance for gaming and video. IPS displays are commonly used in smartphones, monitors, tablets, and TVs, where high-quality visuals and wide viewing angles are essential. The International Organization for Standardization, or ISO, is an independent, non-governmental international body that develops and publishes worldwide standards for a wide range of industries and sectors. ISO's primary mission is to promote global trade by developing standards that ensure quality, safety, efficiency, and interoperability across products and services. ISO standards cover a broad spectrum, including technology, manufacturing, environmental management, information security, and quality management systems. ISO standards are recognized and implemented globally, ensuring consistency, safety, and high-quality practices across different countries and industries. ISO certification demonstrates that an organization has met specific standards, often leading to improved processes, enhanced credibility, and better customer trust. Information Technology Extended refers to a set of compact motherboard form factors designed for small, low-power systems, offering an alternative to standard ATX form factors. The most common ITX form factors include Mini ITX, Micro ITX, and Nano ITX, with Mini ITX being the most popular for compact PCs, home theaters, and small server setups. ITX motherboards are used in systems where space and power consumption are critical, such as small form factor PCs, embedded systems, or energy-efficient devices. ITX motherboards typically support a range of components, including CPUs, RAM, and storage, but have fewer expansion slots and ports compared to larger ATX boards. ITX motherboards are ideal for building compact, efficient computers such as home theater PCs or HTPCs, custom mini PCs, and even some IoT devices. A keyboard, video, and mouse, or KVM switch, is a hardware device that allows multiple computers to be controlled using a single keyboard, monitor, and mouse setup. KVM switches enable users to toggle between different computers or servers without needing separate peripherals for each, reducing desk clutter and saving space. KVM switches come in various configurations, including those supporting 2, 4, or more computers, and can be either analog or digital, with some models offering additional features like remote access. KVM switches are commonly used in data centers, server rooms, and environments where IT administrators need to manage multiple systems from a single workstation. KVM switches simplify system management, reduce the number of peripheral devices needed, and enhance efficiency by enabling centralized control of multiple devices. A local area network, or LAN, is a network of interconnected devices within a limited geographic area, such as a home, office, or campus, allowing for high-speed communication and resource sharing. LANs consist of devices like computers, servers, switches, routers, and printers, which are connected via wired or wireless connections using Ethernet, Wi-Fi, or other networking technologies. LANs enable devices to share resources such as files, printers, and internet access, and facilitate communication through protocols like TCP/IP. LANs provide fast data transfer speeds, typically ranging from 100 megabits per second to 10 gigabits per second, making them ideal for environments where high-performance networking is required. LANs can be secured using measures like firewalls, encryption, and access control to protect against unauthorized access and cyber threats. The Lucent connector, or LC, is a small form-factor fiber optic connector used for high-density, high-performance networking applications. LC connectors feature a compact design with a 1.25mm ferrule, allowing for the connection of fiber optic cables in smaller spaces while maintaining reliable signal transmission. LC connectors are commonly used in data centers, telecommunications, and high-speed networking environments due to their small size and efficient performance. LC connectors provide excellent performance with low insertion loss and high durability, supporting both single-mode and multi-mode fiber cables. The LC connector's compact size and efficient design make it ideal for installations where space is limited, such as in high-density patch panels and fiber optic networks. A liquid crystal display, or LCD, is a flat panel display technology that uses liquid crystals to modulate light and create images, commonly used in computer monitors, TVs, and smartphones. LCDs use a backlight to illuminate the liquid crystals, which change their alignment in response to electric currents, controlling the passage of light through the panel to form images. Common types of LCD technologies include twisted pneumatic, in-plane switching, and vertical alignment, each offering different color accuracy, response times, and viewing angles. LCDs are energy efficient, produce less heat, and are thinner compared to older display technologies like cathode ray tube or CRT monitors, making them ideal for modern devices. LCDs are widely used in TVs, computer monitors, smartphones, tablets, and digital signage due to their high resolution, compact size, and energy efficiency. Lightweight Directory Access Protocol, or LDAP, is a protocol used to access and manage directory services such as Network Directory to store and retrieve data about users, devices, and resources. LDAP is commonly used for storing and querying data in a hierarchical directory structure, enabling centralized authentication and authorization for network resources. LDAP is widely used in enterprise environments for user authentication, managing email directories, and supporting centralized management of network services. LDAP can be secured using Transport Layer Security, or TLS, or Secure Sockets Layer, or SSL, to encrypt communication and ensure data privacy between the client and server. LDAP is often integrated with other services like Active Directory, Open LDAP, and Novell eDirectory to provide a centralized directory for managing network resources and user permissions. A light-emitting diode, or LED, is a semiconductor device that emits light when an electrical current passes through it, used in a variety of display and lighting applications. LEDs work by releasing photons when electrons move through a semiconductor material, making them more energy efficient and durable compared to traditional light sources like incandescent bulbs. LED technology is used in several applications, including LED displays, LED backlighting for LCDs, and as general lighting in residential, commercial, and automotive systems. LEDs are energy efficient, have a long lifespan, and provide bright, clear light with lower heat generation compared to other lighting technologies. LEDs are widely used in televisions, computer monitors, traffic lights, car headlights, and energy-efficient lighting solutions for homes and businesses. Media Access Control, or MAC, refers to a unique identifier assigned to network interfaces for communications on a physical network segment, typically used in Ethernet and Wi-Fi networks. The MAC address is used to ensure that data packets are delivered to the correct device on a local network by uniquely identifying each network interface card, or NIC. A MAC address is a 48-bit address, typically represented as 12 hexadecimal characters, where the first half identifies the manufacturer and the second half is unique to the device. MAC addresses are essential in Layer 2 of the OSI model for packet switching and managing communication within local area networks. MAC address filtering can be used as a security measure to limit access to networks based on the MAC addresses of devices, though it can be bypassed by skilled attackers. A metropolitan area network, or MAN, is a type of network that covers a larger geographical area than a local area network, but is smaller than a wide area network, typically spanning a city or a large campus. MANs are used to connect multiple LANs within a city or metropolitan area, allowing for high-speed data transfer, resource sharing, and communication across a broader region. MANs typically use fiber optic cables, high-speed wireless connections, or leased lines for data transmission, providing fast and reliable networking capabilities. Commonly used by businesses, government institutions, and service providers to link multiple locations within a city, support cloud services, and enable internet access. MANs offer high bandwidth, lower latency, and the ability to connect to multiple LANs over a larger area, making them ideal for urban environments and large organizations. The Master Boot Record, or MBR, is a special type of boot sector located at the beginning of a storage device, such as a hard drive, containing the information necessary for the operating system to boot up. The MBR contains a small program called the bootloader, which is responsible for loading the operating system along with a partition table that defines the partitions on the disk. MBR is limited to supporting up to 4 primary partitions, or 3 primary partitions and 1 extended partition, and it can only address disk sizes up to 2 terabytes. MBR has been largely replaced by the more modern GUID partition table, or GPT, in newer systems, but it's still used for legacy systems and compatibility. When the system is powered on, the MBR is the first sector read by the BIOS, which then executes the bootloader to start the operating system from the appropriate partition. Mobile Device Management, or MDM, refers to a set of technologies and policies used to manage and secure mobile devices such as smartphones, tablets, and laptops within an organization. MDM solutions allow IT administrators to monitor, control, and secure mobile devices remotely, ensuring compliance with organizational policies and protecting sensitive data. Common MDM features include remote device tracking, remote wiping, app management, password enforcement, and security policy deployment. MDM helps organizations maintain security, reduce the risk of data breaches, and ensure that mobile devices are configured and updated according to company standards. MDM is used in enterprise environments to manage both company-owned and bring-your-own-device mobile devices, ensuring secure access to corporate resources. Managed Detection and Response, or MDR, is a cybersecurity service that provides continuous monitoring, threat detection, and incident response to identify and mitigate cyber threats in real time. MDR combines advanced security technologies with human expertise to proactively detect, analyze, and respond to security incidents, often outsourcing these tasks to third-party security providers. MDR services typically include threat intelligence, behavioral analysis, 24/7 monitoring, incident response, and post-event analysis to quickly mitigate potential security risks. MDR helps organizations improve their security posture by providing expert threat analysis, reducing the time to detect and respond to incidents, and enhancing overall threat visibility and awareness. MDR is widely used by businesses of all sizes, especially those without in-house security teams, to protect against sophisticated cyber threats such as ransomware, advanced persistent threats, or APTs, and zero-day attacks. Multi-factor authentication, or MFA, is a security process that requires users to provide 2 or more verification factors to gain access to a system or application, adding an extra layer of protection beyond just a password. MFA typically involves a combination of something you know, like a password, something you have, like a smartphone or hardware token, and something you are, like a biometric data, like fingerprints or facial recognition. MFA significantly enhances security by reducing the likelihood of unauthorized access, even if a password is compromised, as attackers would need to bypass multiple authentication layers. Common MFA methods include SMS or email verification codes, app-based authentication like Google Authenticator, and biometric verification like fingerprints or facial recognition. MFA is widely used in sensitive environments such as banking, corporate networks, and cloud services to secure online accounts, VPNs, and critical infrastructure. The Microsoft Management Console, or MMC, is a Windows-based interface that provides a framework for managing system and network administration tools. MMC allows IT administrators to access and manage various management tools such as Device Manager, Event Viewer, and Disk Management in one unified console. MMC uses snap-ins, which are individual management tools that can be added to the console to perform specific administrative tasks such as managing services, users, or disks. The MMC can be customized by adding or removing snap-ins based on the administrative tasks required, allowing for a tailored experience for managing different systems. MMC is widely used in enterprise environments for tasks like system configuration, troubleshooting, and network management, offering a centralized location for managing Windows servers and workstations. A Mutual Non-Disclosure Agreement, or MNDA, is a legal contract between 2 or more parties where they agree not to disclose confidential information shared between them. The MNDA is used to protect sensitive information, ensuring that both parties maintain confidentiality and do not share or misuse the information for unauthorized purposes. It typically covers trade secrets, proprietary information, business plans, and intellectual property that both parties wish to keep private during discussions, collaborations, or negotiations. Unlike a unilateral NDA, where only one party discloses information, a mutual NDA ensures both parties are equally responsible for protecting the confidentiality of the shared information. MNDA is often used in business partnerships, joint ventures, and negotiations to protect sensitive data and ensure trust between collaborating entities. mSATA, or Mini SATA, is a smaller version of the SATA, or Serial ATA interface used for connecting solid-state drives, or SSDs, to a computer or other devices, offering compact storage solutions. mSATA drives are typically 50mm by 30mm in size, making them much smaller than traditional 2.5-inch SATA SSDs, which is ideal for laptops, tablets, and other compact devices. mSATA provides high-speed data transfer rates similar to standard SATA 3, supporting speeds up to 6 gigabits per second, making it suitable for faster storage in smaller devices. mSATA is often used in ultrabooks, netbooks, and embedded systems, and while it's similar in performance to SATA SSDs, it requires devices specifically designed with an mSATA slot. mSATA drives are commonly used for boot drives, system caching, and performance upgrades in smaller computing devices where space and power efficiency are important. A Material Safety Data Sheet, or MSDS, is a document that provides detailed information about the properties, handling, storage, and hazards of a chemical substance or material. MSDS is designed to ensure the safe use of chemicals by providing important safety information such as potential health effects, fire hazards, reactivity, and protective measures. An MSDS typically includes sections on chemical composition, physical and chemical properties, first aid measures, handling and storage precautions, and regulatory information. MSDS is required by safety regulations like OSHA or the Occupational Safety and Health Administration in workplaces where hazardous chemicals are used, ensuring employee safety and regulatory compliance. MSDS is commonly used in workplaces like laboratories, manufacturing plants, and chemical handling areas to inform workers about the risks and safety protocols associated with chemical products. Mail exchange, or MX, records are a type of DNS or domain name system record used to specify the mail servers responsible for receiving and handling email messages for a domain. MX records direct email traffic to the appropriate mail servers by associating domain names with the server's IP address, ensuring that emails are delivered to the correct recipient. MX records include a priority value, which determines the order in which mail servers are used, allowing for load balancing and failover between multiple mail servers. To configure MX records, a domain's DNS settings must be updated to point to the IP addresses of the designated mail servers. MX records are crucial for email systems, ensuring that emails are routed correctly from the sender's mail server to the recipient's mail server for proper delivery. A non-disclosure agreement, or NDA, is a legal contract between two or more parties that outlines confidential information that cannot be disclosed to others. NDAs are used to protect sensitive information from being shared with unauthorized third parties, typically used during business discussions, partnerships, or employment. There are two common types: unilateral NDAs, where only one party discloses confidential information, and mutual NDAs, or MNDAs, where both parties share confidential information. NDAs typically specify the scope of confidentiality, the duration of the agreement, and the penalty for breach of the agreement. NDAs are widely used in business, employment contracts, mergers, and intellectual property agreements to ensure that proprietary information and trade secrets are protected. Network Basic Input-Output System, or NetBIOS, is an API, or Application Programming Interface, used for communication between computers over a local area network. NetBIOS provides services related to the transport, session, and presentation layers of the OSI model, enabling applications on different computers to communicate over a network. Each device on the network is assigned a unique NetBIOS name, which is used for identification and communication within the network. NetBIOS operates over TCP/IP and can use ports such as 137, 138, and 139 to facilitate communication between devices on the same network. NetBIOS is commonly used in older Windows networks for file sharing, printer sharing, and name resolution, but has largely been replaced by modern protocols like DNS and SMB in newer systems. Near-Field Communication, or NFC, is a short-range wireless communication technology that allows data exchange between devices over a distance of 4 centimeters or less. NFC enables two devices to establish a connection by simply bringing them close together, facilitating quick, secure transactions or data transfers without the need for pairing or complex setup. Common uses of NFC include mobile payments, for example Apple Pay or Google Pay, contactless cards, and data transfer between smartphones or between devices and smart tags. NFC is considered secure for transactions because of its short communication range, which reduces the risk of interception or unauthorized access. NFC is widely used in retail, transportation, and personal electronics for its convenience, speed, and ease of use, especially in mobile payment systems and contactless ticketing. A Network Interface Card, or NIC, is a hardware component that allows computers and other devices to connect to a network, enabling communication over wired or wireless networks. NICs operate at the data link layer of the OSI model, responsible for transmitting and receiving data packets between the computer and the network, typically using Ethernet or Wi-Fi. NICs come in different forms, including wired Ethernet cards using RJ45 connectors and wireless cards using Wi-Fi, supporting various network speeds and technologies. Modern NICs support a range of speeds from 10 over 100 megabits per second for basic connections to gigabit or 1 gigabit per second and even 10 gigabits per second for high-performance networking. NICs are used in almost all network devices, including desktops, laptops, servers, and printers, to enable communication and resource sharing across local area networks and the Internet. The New Technology File System, or NTFS, is a file system developed by Microsoft for use in Windows operating systems, offering improved performance, reliability, and security over older file systems like FAT32. NTFS supports large file sizes, file compression, disk quotas, and encryption, making it ideal for both personal and enterprise-level storage needs. NTFS includes advanced security features such as file-level permissions and encryption via the Encrypting File System, or EFS, to protect sensitive data. NTFS provides better performance than older file systems by supporting larger storage volumes and faster read-write operations, particularly on large disk arrays. NTFS is the default file system for modern Windows operating systems, including Windows 10 and Windows Server, and is used in both personal and business environments for high-capacity storage. Network Time Protocol, or NTP, is a protocol used to synchronize the clocks of computers and devices over a network, ensuring accurate and consistent time across systems. NTP operates by using a hierarchical system of time servers, with each server syncing its time from a more accurate reference clock, such as an atomic clock or GPS time source. NTP can provide time synchronization with an accuracy of milliseconds over local networks and up to several seconds over the Internet, depending on network conditions. NTP can be secured using authentication methods to prevent unauthorized time adjustments and to protect against time-based attacks such as replay or man-in-the-middle attacks. NTP is used in a variety of applications where accurate time is crucial, such as financial transactions, distributed computing, logging events, and network management. Non-Volatile Memory Express, or NVMe, is a high-speed storage protocol designed for accessing non-volatile memory, particularly used in solid-state drives that connect via the PCIe interface. NVMe offers significantly faster data transfer speeds compared to traditional storage protocols like SATA and AHCI by leveraging the high bandwidth of PCIe lanes, delivering improved read-write speeds and lower latency. NVMe is designed to fully exploit the capabilities of modern NAND flash memory, providing faster boot times, quicker file transfers, and enhanced performance for applications that require high-speed storage. NVMe is commonly used in consumer and enterprise SSDs, including in laptops, desktops, and data centers, where high-speed data access is crucial for tasks such as gaming, video editing, and big data processing. NVMe is becoming the standard for SSDs, replacing older protocols like SATA and SAS, and it's continuously evolving to support even faster speeds and more efficient data handling. OLED, or Organic Light Emitting Diode, is a display technology that uses organic compounds to emit light when an electric current is applied, enabling thinner, more flexible screens compared to traditional LCDs. OLED displays offer superior color accuracy, contrast ratios, and faster response times due to their ability to individually light each pixel, allowing for true blacks and vibrant colors. OLED displays are energy efficient because they do not require a backlight like LCDs, as each pixel emits its own light, leading to lower power consumption and better overall performance. OLED technology is widely used in modern devices such as smartphones, televisions, wearable devices, and automotive displays due to its high-quality visual output and thin form factor. While OLED offers exceptional image quality, it can suffer from burn-in, where static images leave a permanent imprint on the screen over time, particularly in applications with fixed elements. An optical network terminal, or ONT, is a device that connects a customer's premises to a fiber optic signal, converting optical signals into electronic signals that can be used by various devices. ONTs are used in fiber optic broadband systems like fiber to the home, or FTTH, or fiber to the premises, or FTTP, enabling high-speed internet, voice, and video services through fiber optic connections. ONTs typically include ports for Ethernet, telephone lines for voice over IP, and sometimes TV connections, making them versatile for multiple communication services. ONTs are often installed by internet service providers at the customer's location, with fiber optic cables running directly to the ONT from the provider's central office or distribution point. ONTs enable faster internet speeds, lower latency, and higher reliability compared to traditional copper-based broadband connections, making them ideal for modern high-demand applications. An operating system, or OS, is system software that manages hardware and software resources on a computer, providing a platform for running applications and facilitating communication between the user and the computer hardware. The OS handles essential tasks such as memory management, file management, task scheduling, and user interface management to ensure efficient system operation. Common operating systems include Windows, Mac OS, Linux, and mobile OSs like Android and iOS, each offering different features, compatibility, and user experiences. OSs typically provide a user interface, either graphical or command line, allowing users to interact with the system, manage files, and execute programs. Modern operating systems include security features such as user authentication, permissions, and automatic updates to protect against malware and keep the system running smoothly. A one-time password, or OTP, is a temporary unique code used for user authentication, typically generated and used in a single login session or transaction. OTPs enhance security by providing an additional layer of authentication, preventing unauthorized access even if a user's primary password is compromised. OTPs can be generated via hardware tokens, software applications, or sent through email or SMS. OTPs are time-sensitive and expire after a short duration, ensuring that even if intercepted, the code cannot be reused for unauthorized access. OTPs are widely used in two-factor authentication systems to secure online banking, email, and other sensitive services. Platform as a Service, or PaaS, is a cloud computing service that provides a platform allowing customers to develop, run, and manage applications without dealing with the underlying infrastructure. Platform as a Service offers integrated development tools, operating systems, databases, and middleware, enabling developers to focus on writing code and developing applications without worrying about managing hardware or software layers. PaaS accelerates the development process, offers scalability, reduces overhead costs, and simplifies application deployment and maintenance. Popular PaaS providers include Microsoft Azure, Google App Engine, and Heroku, each offering a variety of tools and services for application development. PaaS is commonly used for web applications, mobile app development, and APIs, where developers require a streamlined platform to build and deploy applications quickly and efficiently. Privileged Access Management, or PAM, refers to the strategies, tools, and policies used to manage and control access to critical systems and sensitive data by users with elevated privileges. PAM solutions ensure that only authorized individuals have access to systems, networks, or applications with administrative privileges, helping to minimize the risk of data breaches and unauthorized system access. PAM typically includes features such as password vaults, session recording, and access controls, along with real-time monitoring and auditing of privileged account activities. PAM reduces the attack surface by restricting the use of high-level access, automating the management of privileged accounts, and providing detailed logs to detect and prevent malicious activities. PAM is commonly used in enterprise environments, particularly in sectors like banking, healthcare, and government, where securing access to critical infrastructure is paramount. A personal area network, or PAN, is a small localized network typically used to connect devices within an individual's immediate vicinity, such as a smartphone, laptop, and wearable devices. PANs often use wireless technologies like Bluetooth and infrared, as well as wired options like USB, to allow communication between devices in close proximity, typically within 10 meters. PANs are commonly used for connecting personal devices, such as syncing smartphones with laptops, controlling Bluetooth-enabled devices like headphones, or connecting to printers and cameras. PAN can be either wired using cables such as USB or wireless using Bluetooth or Wi-Fi, providing flexibility in how devices communicate with each other. PANs are convenient for personal device management, offering simple and secure connections without the need for complex network configurations or long-range communication. A personal computer, or PC, is a multi-purpose device designed for individual use, typically equipped with hardware components like a processor, memory, storage, and input-output devices. Key components of a PC include the central processing unit, or CPU, motherboard, memory or RAM, storage, SSD or HDD, graphics card, and peripheral devices such as the keyboard, mouse, and monitor. PCs come in various forms, including desktops, laptops, and all-in-one computers, each serving different purposes based on portability, performance, and user needs. Personal computers typically run operating systems such as Windows, Mac OS, or Linux, which provide a user interface to allow users to run applications, manage files, and connect to networks. PCs are widely used for tasks like word processing, internet browsing, gaming, multimedia, software development, and business operations. Peripheral Component Interconnect, or PCI, is a standard for connecting peripheral devices to a computer's motherboard, enabling communication between the motherboard and expansion cards. PCI slots allow devices like graphics cards, network cards, sound cards, and storage controllers to be added to the computer, expanding its capabilities. PCI has evolved through several versions, including PCI 2, PCI 3, and PCI Express, each offering faster data transfer speeds and greater bandwidth, with PCIe being the most widely used in modern systems. PCI provides a standardized interface for expansion cards, ensuring compatibility and ease of installation in desktop computers and servers. PCI is commonly used in personal computers, servers, and workstations to add additional hardware such as graphics cards, network adapters, and storage devices. PCI Express, or PCIe, is a high-speed serial expansion card interface used to connect peripherals like graphics cards, storage devices, and network cards to a computer's motherboard. PCIe uses lanes, with each lane consisting of 2 pairs of wires for sending and receiving data, allowing for faster communication compared to older parallel interfaces like PCI. PCIe provides significantly higher data transfer speeds and bandwidth, with each version offering improved performance, supporting speeds ranging from 8 gigatransfers per second to 32 gigatransfers per second. PCIe slots come in different sizes such as X1, X4, X8, and X16, allowing for different numbers of lanes, with X16 slots typically used for high-performance devices like graphics cards. PCIe is widely used in desktops, laptops, and servers to support high-speed devices such as GPUs, SSDs, networking cards, and other expansion cards that require fast data transfer rates. Personally Identifiable Information, or PII, refers to any data that can be used to identify, contact, or locate a specific individual, either directly or indirectly. PII includes sensitive information such as names, social security numbers, addresses, email addresses, phone numbers, and biometric data. Protecting PII is essential for maintaining privacy and security, as its exposure can lead to identity theft, fraud, and other harmful consequences. Various laws and regulations such as the GDPR, or General Data Protection Regulation, and CCPA, or California Consumer Privacy Act, mandate strict guidelines for handling and protecting PII. PII is commonly collected in industries like finance, healthcare, e-commerce, and government for customer identification, transactions, and record keeping. A personal identification number, or PIN, is a secret numeric code used for authentication, typically consisting of 4 to 6 digits, that helps verify the identity of an individual accessing secure systems or accounts. PINs are commonly used in conjunction with other authentication methods, such as passwords or smart cards, to provide two-factor authentication for enhanced security. PINs offer a basic level of security, but their effectiveness can be compromised if the PIN is too simple or easily guessed, making it important to choose a secure and unique PIN. PINs are widely used in banking for ATM transactions, mobile devices for unlocking phones, and other systems requiring secure access to personal or sensitive information. Some systems use biometric data, smart cards, or multi-factor authentication to improve security in environments where PINs alone may not be sufficient. Personal Identity Verification, or PIV, is a government-issued identification card used to authenticate and authorize access to secure systems and facilities, primarily for U.S. federal employees and contractors. The PIV card integrates multiple security features, such as a smart card, biometric data, and cryptographic certificates to ensure the identity of the cardholder. PIV cards provide multi-factor authentication by combining something you have with something you know and something you are. PIV cards are used in federal government systems for accessing buildings, logging into computer networks, and securing sensitive data, ensuring compliance with security standards such as FIPS 201. The PIV system is mandated by the U.S. government under Homeland Security Presidential Directive 12 to improve identification security in government agencies. Power over Ethernet, or PoE, is a technology that allows Ethernet cables to carry electrical power alongside data to devices such as IP cameras, wireless access points, and VoIP phones. PoE eliminates the need for separate power cables by providing both data connectivity and electrical power through a single Ethernet cable, simplifying installation and reducing cable clutter. PoE operates under standards like IEEE 8023AF, providing up to 15.4 watts of power, and IEEE 8023AT, Power over Ethernet Plus, which provides up to 25.5 watts, with newer standards like IEEE 8023BT offering even higher power levels up to 60 watts or more. PoE simplifies infrastructure by reducing the number of cables needed, improves flexibility in device placement, and can reduce costs associated with additional power supplies and outlets. PoE is commonly used in network devices like security cameras, access points, and VoIP phones, as well as smart lighting and other IoT devices that require both data and power. Post Office Protocol, or POP, is an email retrieval protocol that allows users to download email messages from a mail server to their local device for offline access. POP has evolved through different versions, with POP 3 being the most widely used. POP 3 provides enhanced functionality over earlier versions by supporting features like better handling of large messages and folder management. POP works by downloading messages to the local client and removing them from the server, meaning the emails are stored on the user's device rather than the server once retrieved. Because POP deletes emails from the server after download, it can be problematic for users who need to access their emails from multiple devices or want to keep messages stored on the server. POP is commonly used for simple email retrieval, where users need access to messages offline or want to store emails locally, but it's less common now due to the rise of IMAP, which offers better synchronization across devices. Power on self-test, or POST, is a diagnostic process that occurs when a computer is powered on, during which the system checks its hardware components to ensure they're functioning properly. POST checks essential hardware components, such as the CPU, RAM, storage devices, and motherboard, to verify they're working before the operating system is loaded. If POST detects any issues, it typically generates error codes or beeps, depending on the system, to alert the user to the problems such as memory errors or a missing hard drive. The POST process is typically very short, lasting only a few seconds, and is followed by the bootloader phase where the operating system is loaded into memory. POST is a critical part of the boot process that ensures the system is ready for use and helps prevent the loading of an operating system if hardware issues are detected. A potentially unwanted program, or PUP, is a type of software that can be installed on a computer without the user's full consent and could negatively affect system performance, security, or privacy. PUPs typically come bundled with other software such as free applications or downloads, and may include toolbars, adware, or bloatware that degrade system performance or display unwanted ads. While not necessarily malicious, PUPs can slow down the system, clutter the user interface, and sometimes collect user data or display intrusive ads, posing a risk to privacy. PUPs can often be removed through antivirus software or using system cleaning tools which scan for and eliminate unwanted applications and associated files. To avoid PUPs, users should be cautious when downloading software, opt for custom installation, to deselect unwanted add-ons, and regularly run malware scans. Radius, or Remote Authentication Dial-In User Service, is a network protocol used for centralized authentication, authorization, and accounting to manage access to network resources. Radius allows a central server to authenticate users who are attempting to access a network, ensuring they have the necessary credentials and permissions for network access. Radius helps secure network access by encrypting user credentials and supporting strong authentication methods such as multi-factor authentication. It's commonly used in enterprise environments to manage access to wired and wireless networks, VPNs, and other network services. Radius simplifies network management by centralizing user authentication and accounting, providing better control over access policies, and simplifying user management. RAID, or Redundant Array of Independent Disks, is a data storage technology that combines multiple physical disk drives into one logical unit for improved performance, redundancy, or both. Common RAID levels include RAID 0 or striping, RAID 1 or mirroring, RAID 5 or striping with parity, and RAID 10 combining striping and mirroring, each offering different balances of speed, redundancy, and storage efficiency. RAID uses various configurations to distribute data across multiple disks, ensuring faster read-write operations, fault tolerance, or protection against disk failure, depending on the level chosen. RAID is commonly used in servers, data centers, and workstations to enhance performance and provide data redundancy, ensuring continuous access to critical data. RAID provides increased storage capacity, enhanced data protection, and improved speed for systems that require large-scale storage or mission-critical applications. Random access memory, or RAM, is a type of volatile memory used by computers to store data that's actively being processed or accessed by the CPU. RAM provides fast read and write access to data, enabling programs and processes to run quickly by temporarily storing data and instructions needed for immediate tasks. Common types of RAM include DDR, or double data rate, DDR2, 3, and 4, with DDR5 being the most current and offering faster speeds and improved power efficiency. The size of RAM, measured in gigabytes, directly affects a system's ability to handle multiple applications simultaneously, with more RAM enabling smoother multitasking and better performance. RAM is volatile, meaning it loses all stored data when the system is powered off, making it temporary storage compared to permanent storage like hard drives or SSDs. Remote Desktop Protocol is a proprietary protocol developed by Microsoft that enables users to connect to and control a remote computer or server over a network. RDP allows users to access a remote desktop interface, enabling them to interact with the remote system as though they were sitting in front of it, with support for graphical user interface and application access. RDP can be secured through encryption, network-level authentication or NLA, and multi-factor authentication or MFA to ensure that remote access is authorized and data is protected. RDP is widely used in business environments for remote administration, IT support, and enabling employees to work remotely, providing them with access to their office desktops and applications. RDP allows for efficient use of network resources, offering features like compression and bandwidth management to provide a responsive experience even over slower connections. Resilient File System, or REFS, is a file system developed by Microsoft designed to provide high data availability, scalability, and reliability primarily for enterprise-level storage solutions. REFS is optimized for handling large volumes of data, supporting features like data integrity checking, automatic error correction, and the ability to handle very large storage capacities. REFS offers built-in protection against data corruption with features like checksums for both metadata and data, and it supports data deduplication and efficient storage management. REFS is commonly used in file servers, data centers, and other high-demand environments where data integrity and uptime are critical, such as with storage spaces and virtual machines. Although REFS offers advanced features, it does not support certain functionalities available in NTFS, such as booting from an REFS drive or running certain types of legacy applications. Radio Frequency Identification, or RFID, is a technology used to automatically identify and track objects, animals, or people using radio waves and RFID tags attached to them. RFID systems consist of two main components: RFID tags, which store data, and RFID readers, which communicate with the tags using radio waves. RFID tags use electromagnetic fields to transmit data to a reader, which then decodes the information for identification, tracking, or data retrieval purposes. There are two main types of RFID tags: passive tags, which rely on the reader for power, and active tags, which have their own power source to increase range and capabilities. RFID is widely used in supply chain management, inventory tracking, access control, and contactless payment systems like RFID-enabled credit cards or transit passes. RJ11 is a standard for a telephone connector commonly used for connecting telephones to landline phone networks. RJ11 uses a 6-position 2-conductor 6P2C wiring configuration, though it can also support 6P4C or 4 conductors for additional functionality like caller ID or multiple phone lines. RJ11 connectors are used primarily for analog voice signals, transmitting data for voice communication through landline phone systems. RJ11 is most commonly found in residential and small business phone lines for connecting telephones, fax machines, and modems to the telephone network. While RJ11 is widely used for basic telephone services, it's limited to lower data transfer speeds and is gradually being replaced by more modern technologies like VoIP. RJ45 is a standard connector commonly used for Ethernet networking, allowing devices like computers, routers, and switches to connect to a local area network or LAN via twisted pair cables. RJ45 connectors feature an 8-position 8-conductor or 8P8C wiring configuration, providing 8 pins to support high-speed data transmission over Cat5, Cat5e, Cat6, and Cat6a cables. RJ45 is used for both data and voice communications, supporting high-speed Ethernet connections with speeds ranging from 10 megabits per second to 10 gigabits per second, depending on the cable type and network standard. RJ45 connectors are essential for wired Ethernet networks, commonly used in homes, businesses, data centers, and telecommunication setups for internet access and local communication. RJ45 connectors provide reliable high-speed and cost-effective network solutions, ensuring stable connections for devices in wired networks. Remote Monitoring and Management, or RMM, refers to the tools and processes used by IT professionals to remotely monitor and manage the health, performance, and security of network devices and systems. RMM software allows IT administrators to perform system maintenance, troubleshoot issues, deploy updates, and monitor devices in real time, all without being physically present at the location. RMM tools typically include features such as automated patch management, performance monitoring, remote access, antivirus integration, and alerting for system failures or security threats. RMM is widely used by managed service providers or MSPs to offer proactive IT support and services to clients, reducing downtime and ensuring that systems remain secure and optimized. RMM improves operational efficiency by enabling centralized control over multiple systems, reduces the need for on-site visits, and allows for quick resolution of issues, improving overall IT service quality. RSR, or Radio Signal Receiver, refers to a device or component that receives and decodes radio frequency signals, typically used in wireless communication systems such as Wi-Fi, cellular, or radio networks. RSRs work by capturing electromagnetic waves or radio signals through antennas, then converting these signals into data that can be processed by the receiving system, such as a phone or computer. RSR technology is essential in wireless communication devices like smartphones, routers, and radios, where it enables connectivity and data transmission over the air. The effectiveness of an RSR can be influenced by factors like signal strength, interference, frequency band, and the quality of the antenna, all of which impact data reception and transmission speed. By enabling wireless communication, RSRs facilitate mobile networking, data transmission, and other applications that rely on wireless technologies, offering flexibility and mobility in modern communications. Software as a Service, or SaaS, is a cloud computing model where software applications are hosted and managed by a third-party provider and accessed over the internet by users. SaaS eliminates the need for organizations to install, manage, and maintain software on local devices, offering applications via web browsers or thin clients. SaaS provides scalability, cost efficiency, and flexibility, allowing businesses to pay for software on a subscription basis, reducing the need for upfront investment in infrastructure or maintenance. Common SaaS applications include Google Workspace, Microsoft 365, Salesforce, and Dropbox, which offer productivity, collaboration, and file storage services on a subscription model. SaaS providers handle security, updates, and backups, ensuring that software remains secure, up-to-date, and continuously available for users. Security Assertion Markup Language, or SAML, is an XML-based framework used to exchange authentication and authorization data between identity providers and service providers, enabling single sign-on across multiple applications. SAML allows users to authenticate once and gain access to different systems without needing to log in separately to each application, improving user experience and security. The primary components of SAML include the identity provider, or IDP, which authenticates the user, and the service provider, or SP, which provides the access to resources after receiving the authentication assertion. SAML ensures secure communications between the IDP and SP by using cryptographic techniques to protect the data during the exchange process, such as digital signatures and encryption. SAML is commonly used in enterprise environments to enable SSO for accessing multiple applications such as cloud-based services, web apps, and enterprise resource management systems. A storage area network, or SAN, is a high-speed dedicated network that provides access to block-level storage, allowing multiple servers to share and access storage devices over a centralized network. SANs use protocols like Fiber Channel, iSCSI, and FCOE, or Fiber Channel over Ethernet, to connect servers and storage devices, enabling faster and more efficient data storage and retrieval. SANs improve performance by providing dedicated storage resources, enabling high availability, scalability, and disaster recovery capabilities for enterprise-level applications. SANs are commonly used in large data centers, enterprise environments, and cloud storage systems to support applications that require high-performance storage, such as databases, virtualization, and backup systems. SANs simplifies storage management by centralizing storage resources, allowing IT administrators to allocate and manage storage more efficiently across multiple systems. Serial Attached SCSI, or SAS, is a high-speed data transfer protocol used for connecting storage devices, such as hard drives and solid-state drives, to computer's storage controller. SAS improves upon the older parallel SCSI standard by providing faster data transfer speeds, better scalability, and improved reliability, supporting both enterprise and high-performance storage environments. SAS supports data transfer rates up to 12 gigabits per second, with multiple lanes for faster access to storage devices, making it ideal for servers, workstations, and storage arrays that require high throughput and low latency. SAS devices are backward compatible with serial ATA devices, allowing for flexible configurations where lower-cost SATA drives can be used alongside higher-performance SAS drives in the same system. SAS is commonly used in enterprise environments such as data centers and servers, where high availability, performance, and scalability are critical for handling large volumes of data. Serial ATA, or SATA, is a data transfer interface used to connect storage devices like hard drives, solid-state drives, and optical drives to a computer's motherboard. SATA uses a serial communication protocol to transmit data, offering faster speeds, smaller cables, and improved reliability compared to the older parallel ATA or PATA interface. SATA provides data transfer rates starting at 1.5 gigabits per second for SATA 1, with newer versions like SATA 2 offering 3 gigabits per second and SATA 3 offering 6 gigabits per second, supporting higher speeds and faster data transfer and storage performance. SATA is widely compatible with a variety of storage devices, including HDDs, SSDs, and optical drives, and is commonly used in desktops, laptops, and servers for both consumer and enterprise storage needs. SATA is commonly used for connecting internal storage devices in computers and is the standard interface for most personal computing systems, offering a reliable and cost-effective solution. A subscriber connector, often referred to as an SC connector, is a fiber optic connector used in communication systems to connect fiber optic cables to network devices such as switches, routers, and optical transceivers. The SC connector is designed with a push-pull mechanism, making it easy to insert and remove, and features a square-shaped body for a stable connection and reliable performance. SC connectors are used in single-mode and multi-mode fiber optic cables, providing low insertion loss and high precision for signal transmission over long distances. SC connectors are widely used in data centers, telecommunications, and network infrastructure for high-speed, high-performance optical networking. The SC connector's secure and simple connection process, along with its durability, makes it suitable for environments that require reliable, high-quality fiber optic connections. SCADA, or Supervisory Control and Data Acquisition, is a system used for monitoring and controlling industrial processes, infrastructure, and facility-based operations in real time. SCADA systems collect data from sensors and devices, process this information, and provide operators with tools to control and monitor critical systems such as water treatment plants, electrical grids, and manufacturing processes. SCADA systems typically consist of remote terminal units, or RTUs, programmable logic controllers, or PLCs, and a central supervisory system, SCADA software, and communication infrastructure to facilitate data flow. SCADA is commonly used in utilities, electricity, water, gas, and more, manufacturing, transportation, and other critical infrastructure sectors that require real-time monitoring and automated control. Due to their critical nature, SCADA systems are targeted by cyber threats, requiring robust security measures, including firewalls, encryption, and access control to protect sensitive data and operational integrity. Small Computer System Interface, or SCSI, is a set of standards used for connecting and transferring data between computers and peripheral devices like hard drives, scanners, and printers. SCSI allows multiple devices to be connected to a single bus, supporting simultaneous data transfer to and from multiple devices without significant performance degradation. SCSI comes in different types such as parallel SCSI and serial attached SCSI, with SAS providing faster speeds and better performance in modern systems. SCSI is commonly used in servers, high-performance workstations, and storage arrays due to its ability to handle large volumes of data and support high-speed devices. SCSI supports a wide range of devices, offers excellent data transfer rates, and provides features like daisy chaining, allowing for flexible and scalable storage solutions. A Subscriber Identity Module, or a SIM, is a small card used in mobile devices such as smartphones to store information related to the user's identity and their mobile network subscription. The SIM card securely stores data such as the user's phone number, contacts, and security keys, allowing the mobile device to connect to the cellular network for voice, text, and data services. There are different types of SIM cards, including standard SIM, micro SIM, nano SIM, and embedded SIM, or eSIM, with eSIM offering more flexibility by being programmable and not requiring a physical card. SIM cards enhance security by encrypting communication between the mobile device and the cellular network, preventing unauthorized access to personal data and mobile services. SIM cards are used globally in mobile phones, IoT devices, and some embedded systems, ensuring user authentication, data encryption, and seamless connectivity across different networks. A Service Level Agreement, or SLA, is a formal contract between a service provider and a customer that defines the expected level of service, including specific performance metrics and service expectations. SLAs typically include details about service uptime, response times, resolution times, support availability, and penalties or remedies if the agreed service levels are not met. The SLA sets clear expectations for both the customer and the service provider, ensuring mutual understanding of service requirements, performance standards, and responsibilities. SLAs help ensure consistent service quality, improve accountability, and provide a mechanism for resolving disputes and addressing issues related to service performance. SLAs are commonly used in IT services, cloud services, and outsourcing agreements, where performance and service reliability are critical to customer satisfaction. SMART, or Self-Monitoring Analysis and Reporting Technology, is a monitoring system built into hard drives and solid-state drives to detect and report various indicators of drive health and performance. SMART tracks parameters such as temperature, read-write error rates, bad sectors, and overall disk health to predict potential hardware failures before they occur. SMART-enabled drives can generate alerts or error reports when they detect abnormal behavior, allowing users or IT administrators to take action, such as backing up data or replacing the drive. SMART helps increase data reliability by providing early warnings of potential failures, reducing the risk of unexpected data loss and downtime. SMART is used in both consumer and enterprise environments to monitor drive health, especially in mission-critical systems where data integrity and system uptime are crucial. Server Message Block, or SMB, is a network file sharing protocol that enables applications and users to access files, printers, and other network resources on a local area network, or LAN. SMB allows for the sharing of files and resources between devices running on Windows, Linux, and Mac OS using a client-server model to facilitate communication and data exchange. SMB has undergone several updates, with SMB1 being the original version and newer versions like SMB2 and SMB3 offering improved speed, security, and reliability. SMB includes security features such as encryption, signing and access control lists, or ACLs, to secure data transfer between devices and ensure only authorized users can access shared resources. SMB is commonly used for file sharing, printer sharing, and network browsing in both home and enterprise environments, facilitating the exchange of information between devices on the same network. Short Message Service, or SMS, is a communication protocol used for sending text messages over cellular networks, typically limited to 160 characters per message. SMS allows users to send short text messages, including alphanumeric characters, between mobile devices or from devices to other communication systems. SMS is widely used for personal communication, business alerts, verification codes, and marketing campaigns due to its simplicity and wide support across mobile networks. SMS is limited by character length, and while it's reliable, it does not support advanced media like images or videos, which is now handled by Multimedia Messaging Service, or MMS. SMS is considered secure for basic communication, but can be vulnerable to phishing attacks or spoofing, especially when used for two-factor authentication or verification purposes. Simple Mail Transfer Protocol, or SMTP, is an internet standard for sending and routing email messages between mail servers. SMTP is responsible for sending emails from a client to a server and between servers, ensuring that emails are properly routed and delivered to the recipient's inbox. SMTP typically operates on port 25, though secure versions use port 587 or 465 for encrypted communication using StarTLS or SSL-TLS. SMTP is primarily used for sending emails, but it does not handle receiving or storing messages, which is managed by protocols like POP3 or IMAP. SMTP is widely used by email clients, servers, and service providers to ensure the reliable and secure transmission of emails across the internet. Small Outline Dual Inline Memory Module, or SODIMM, is a type of memory module used in laptops, small form-factor computers, and other space-constrained devices, offering a compact version of the standard DIMM used in desktops. SODIMMs are smaller than regular DIMMs, typically 2.66 inches long, and are designed to fit in tight spaces like those found in portable and compact devices. SODIMMs are used to provide RAM, or random access memory, in laptops and small devices, allowing them to run applications, store temporary data, and enhance system performance. SODIMMs are available in various types, including DDR, DDR2, DDR3, and DDR4, with DDR5 being the most commonly used in modern systems, offering higher speeds and lower power consumption. SODIMMs are used primarily in laptops, notebooks, all-in-one computers, and compact devices where space saving and energy efficiency are important. Small Office Home Office, or SOHO, refers to a small-scale business environment typically with fewer than 10 employees or a personal workspace that is set up in a home for work-related activities. SOHO networks often consist of basic networking equipment such as routers, switches, wireless access points, and computers, enabling communication, internet access, and file sharing within the home or office. In SOHO environments, devices are typically connected to the internet through broadband services like cable or DSL, and they may utilize cloud-based services for data storage, communication, and business applications. Since SOHO networks often handle sensitive information, it's important to implement security measures like firewalls, encryption, and strong password practices to protect against cyber threats. SOHO setups are common among freelancers, remote workers, and small businesses, providing essential infrastructure for daily operations, including email, internet access, and file sharing. A standard operating procedure, or SOP, is a set of step-by-step instructions compiled by an organization to help workers perform routine operations and maintain consistency in operations. SOPs are designed to ensure that employees perform tasks in a standardized and efficient manner, minimizing errors, improving quality, and complying with regulatory requirements. SOPs help improve operational efficiency, reduce training time for new employees, ensure compliance with safety and quality standards, and maintain consistency in output across various departments. SOPs are used across various industries, including IT, healthcare, manufacturing, and customer service, to document processes ranging from system maintenance to client interactions. To be effective, SOPs should be clear, concise, regularly reviewed, and updated to reflect changes in processes, regulations, or technologies. Sender Policy Framework, or SPF, is an email authentication protocol used to prevent email spoofing by verifying that incoming email messages are from authorized mail servers. SPF works by checking the sender's IP address against a list of authorized IPs published in the DNS records of the sending domain, ensuring the email comes from a legitimate source. SPF helps protect against phishing attacks and email fraud by verifying that emails are sent from trusted sources, reducing the likelihood of malicious emails reaching recipients. SPF does not verify the entire email content and cannot protect against all types of email fraud, such as emails with spoofed display names, making it used often in conjunction with other protocols like DKIM and DMARC. SPF is widely used in organizations' email security strategies to improve deliverability, prevent spam, and maintain the integrity of email communications. SPICE, or Simple Protocol for Independent Computing Environments, is an open-source remote desktop protocol designed to provide efficient access to virtualized desktops and remote systems over a network. SPICE is commonly used in virtual desktop infrastructure, or VDI, and remote desktop applications to enable graphical desktop access to virtual machines and remote systems. SPICE supports features such as high-quality video, audio, and USB redirection, along with low latency and compression techniques, ensuring a smooth user experience even in resource-constrained environments. It's an open-source solution, making it cost-effective and provides seamless integration with KVM or kernel-based virtual machine hypervisor and other Linux-based systems. SPICE ensures secure communication between clients and servers by using SSL TLS encryption, offering a secure channel for remote desktop access. SQL, or SQL, or Structured Query Language, is a standardized programming language used to manage and manipulate relational databases by querying, updating, inserting, and deleting data. SQL allows users to interact with databases using commands such as select, insert, update, delete, and join to retrieve or modify data in structured formats. SQL commands are classified into different categories, including Data Query Language, or DQL, Data Definition Language, or DDL, Data Manipulation Language, or DML, and Data Control Language, or DCL. SQL is used in a wide range of applications, including web development, business analytics, and data management, enabling efficient data storage, retrieval, and reporting. SQL simplifies data management, provides powerful querying capabilities, and is used across many relational database management systems, or RDBMS, like MySQL, PostgreSQL, and Microsoft SQL Server. A solid-state drive, or SSD, is a data storage device that uses NAND flash memory to store data, offering faster speeds and greater reliability compared to traditional hard disk drives, or HDDs. SSDs use flash memory to read and write data, eliminating the mechanical moving parts found in HDDs, which results in quicker data access, improved performance, and lower power consumption. Common SSD types include SATA SSDs, which use the same interface as HDDs, and NVMe SSDs, which connect via the PCIe interface for even faster data transfer rates. SSDs provide faster boot times, quicker file access, lower energy consumption, and greater durability due to the lack of moving parts, making them ideal for performance-critical applications. SSDs are used in consumer devices like laptops and desktops, as well as in servers and data centers, where speed and reliability are essential for handling large data loads. Secure Shell, or SSH, is a cryptographic network protocol used for secure communication between two devices over an unsecured network, often used for remote server access and command line operations. SSH allows users to securely log into remote systems, transfer files, and execute commands on remote devices, with all data encrypted to prevent interception. SSH uses encryption, public and private key pairs, and authentication methods to ensure secure communication and protect sensitive data during transmission. SSH is commonly used by system administrators to manage servers, perform remote maintenance, and securely transfer files, often replacing older protocols like Telnet and FTP due to its higher security. SSH provides strong security through encryption, helps prevent unauthorized access, and ensures data integrity, making it an essential tool for managing remote systems in secure environments. Service Set Identifier, or SSID, is a unique name assigned to a wireless network used to distinguish it from other networks in the area. SSID is broadcast by a wireless access point or AP to allow devices to identify and connect to the correct network. It can be either visible or hidden depending on the network settings. The SSID itself does not provide security, but can be secured by using WPA, WPA2, or WPA3 encryption to protect the network from unauthorized access. SSIDs are commonly used in homes, offices, and public places to identify and provide access to wireless networks such as Wi-Fi in a home or coffee shop. Users can change the SSID on their wireless router to personalize the network name and improve security by hiding the SSID to prevent unauthorized devices from easily discovering the network. Single sign-on, or SSO, is an authentication process that allows users to access multiple applications or systems with a single set of login credentials, eliminating the need for logging in repeatedly. SSO works by authenticating the user once, generating an authentication token, and allowing access to various connected systems or services without re-entering credentials. SSO enhances security by reducing the number of times a user must enter login credentials, lowering the risk of password fatigue, and improving password management practices. SSO is commonly used in enterprise environments, web applications, and cloud services to streamline the user experience and improve access control for employees, customers, and partners. SSO can be integrated with other identity and access management technologies like LDAP, SAML, and OAuth, to enable secure and centralized user authentication across a wide range of applications. The straight tip connector, or ST connector, is a type of fiber optic connector commonly used for multi-mode fiber optic cables, known for its bayonet-style coupling mechanism, which allows for a secure connection. ST connectors are typically used in legacy fiber optic systems, particularly in networking and telecommunications, and are popular in older installations due to their reliability and ease of use. The ST connector features a cylindrical shape with a spring-loaded mechanism for quick and easy coupling and decoupling, with a ceramic ferrule to align the fiber core precisely. The ST connector is known for its durability, providing a secure and stable connection that minimizes the risk of signal loss or degradation during transmission. While the ST connector is still widely used, it's being replaced by newer installations by more modern connectors like the SC and LC types due to their compact size and ease of handling. TACACS, or Terminal Access Controller Access Control System, is a protocol used for remote authentication and authorization in network devices, allowing administrators to control access to routers, switches, and other network equipment. TACACS works by sending user credentials to a centralized server where authentication and authorization decisions are made, ensuring secure access to network resources. TACACS provides strong security by encrypting the entire communication between the client and the server, protecting sensitive authentication data from unauthorized interception. While both TACACS and Radius are used for network access control, TACACS provides more granular control over authentication, authorization, and accounting, or AAA, and is often preferred for device-level access control. TACACS is commonly used in large enterprise networks to centralize authentication and manage network device access for administrative purposes. Transmission Control Protocol, or TCP, is a core protocol of the Internet Protocol Suite that ensures reliable, ordered, and error-free delivery of data between computers over a network. TCP divides data into packets, numbers them, and ensures that all packets are received correctly and in order using techniques like acknowledgements and retransmissions. TCP is a connection-oriented protocol, meaning a connection is established between the sender and receiver before transmission begins, ensuring reliability and data integrity. TCP manages flow control and congestion control to avoid network congestion and ensure that data is sent at an appropriate rate. TCP is widely used in applications requiring reliable communication, such as web browsing, email, file transfer, and remote login. Temporal Key Integrity Protocol, or TKIP, is a security protocol used in wireless networks to provide encryption and ensure the integrity of data during transmission, particularly in Wi-Fi networks. TKIP is an improvement to WEP, or Wired Equivalent Privacy, providing stronger encryption and dynamic key management to prevent certain vulnerabilities inherent in WEP. TKIP uses per-packet keying, which dynamically generates a unique key for each data packet, reducing the risk of attacks like key reuse and improving overall security. TKIP was widely used in Wi-Fi networks, especially under the WPA, or Wi-Fi Protected Access Standard, to replace WEP's weaknesses and enhance security. While TKIP improved security over WEP, it's considered less secure than modern encryption standards like AES or Advanced Encryption Standard, and its use is being phased out in favor of stronger security protocols. Twisted Pneumatic, or TN, is a type of liquid crystal display technology, or LCD technology, commonly used in computer monitors and television screens, known for its fast response time and lower cost. TN displays work by using liquid crystals that twist when an electric current is applied, controlling the light passing through to form the image on the screen. TN displays are known for their fast refresh rates and response times, making them ideal for gaming and fast-moving visuals, along with being more affordable compared to other display technologies like IPS or OLED. The primary drawbacks of TN technology are its narrow viewing angles and poor color accuracy compared to IPS or in-plane switching or VA, vertical alignment displays. TN displays are widely used in budget-friendly computer monitors, gaming displays, and laptops where speed is a priority over color quality and viewing angles. Time-based one-time password, or TOTP, is an authentication protocol that generates a one-time password based on the current time, providing an additional layer of security for user authentication. TOTP uses a shared secret key and the current time to generate a temporary time-sensitive password that's valid only for a short period, typically 30 seconds. TOTP enhances security by reducing the risk of password theft, as the generated password is valid only for a limited time and cannot be reused once it expires. TOTP is widely used in two-factor authentication systems such as mobile banking apps, online services, and email providers to ensure secure user access. Common tools for generating TOTP include authentication apps like Google Authenticator and Authy, which use the TOTP algorithm to generate time-sensitive codes for user login. Trusted Platform Module, or TPM, is a hardware-based security feature integrated into computers and devices to provide encryption and secure storage of sensitive data such as passwords, encryption keys, and certificates. TPM provides secure cryptographic operations, enabling features like full disk encryption, for example BitLocker, secure boot, and hardware-based authentication, which enhances system security and data protection. TPM protects against unauthorized access and tampering by securely storing sensitive data in a dedicated chip, isolated from the operating system and external threats. TPM is widely used in enterprise environments for device security, securing confidential data, and ensuring compliance with industry standards and regulations such as GDPR and HIPAA. TPM 2.0 has become a requirement for newer Windows operating systems like Windows 11 to enable advanced security features such as Secure Boot and Windows Hello. User Account Control, or UAC, is a security feature in Microsoft Windows that helps prevent unauthorized changes to the operating system by prompting users for permission or an administrator password when performing tasks that require elevated privileges. UAC works by creating a separation between standard user accounts and administrator accounts, requiring additional approval before administrative tasks are carried out, reducing the risk of malware or unauthorized software making system changes. UAC enhances security by limiting the actions of potentially harmful programs, preventing them from making system-wide changes without the user's consent and helping protect against malicious software. Users can customize UAC settings to control how often they're prompted for permission, ranging from never notifying to always notifying, depending on their preferred security level. UAC is especially useful in environments where security is a priority, such as corporate networks, or on personal devices where users want to prevent unauthorized changes from malicious software. User Datagram Protocol, or UDP, is a connectionless communication protocol used in networking for transmitting data between devices without establishing a connection first, making it faster but less reliable than TCP. UDP sends data packets known as datagrams without ensuring their delivery, ordering, or error correction, allowing for low latency communication in scenarios where speed is more critical than reliability. UDP is commonly used in applications such as video streaming, VoIP, and online gaming, where real-time performance is more important than guaranteed delivery. UDP provides reduced overhead and faster transmission, as there's no need for establishing and maintaining a connection, making it ideal for time-sensitive applications. Due to its lack of error checking and correction, UDP is less reliable than protocols like TCP, meaning data loss or corruption can occur without notification. Unified Extensible Firmware Interface, or UEFI, is a modern firmware interface that replaces the older BIOS, or Basic Input-Output System, to initialize hardware and boot the operating system into a computer system. UEFI offers a more flexible and feature-rich environment than BIOS, providing faster boot times, support for large hard drives over 2 TB, and a graphical user interface, or GUI, for easier configuration. UEFI includes built-in security features such as Secure Boot, which helps prevent unauthorized operating systems and bootloaders from loading, providing protection against bootkit and rootkit attacks. UEFI supports both 32-bit and 64-bit systems and can boot both from GPT, or GUID partition table, and MBR, or master boot record partition schemes, although GPT is recommended for newer systems. UEFI is used in modern computers, laptops, and servers, offering improved performance, security, and configuration options compared to the traditional BIOS. Universal Plug-and-Play, or UPnP, is a set of networking protocols that allows devices on a local network to discover and communicate with each other, enabling automatic configuration of network devices. UPnP simplifies device setup by allowing devices such as printers, cameras, and media servers to be automatically recognized and configured by other devices on the network without manual intervention. UPnP is commonly used in home networks for devices like routers, smart TVs, gaming consoles, and IoT devices, making it easier for users to connect and use them without complex configuration. While UPnP provides convenience, it can pose security risks if not properly managed, as it can expose devices to external access if enabled on routers and left unprotected. UPnP offers ease of use, especially in dynamic environments where devices frequently join and leave the network, allowing for seamless connectivity and functionality. An uninterruptible power supply, or UPS, is a device that provides backup power to connected devices in the event of a power outage or fluctuation, ensuring continuous operation. A UPS provides emergency power by using its internal battery to supply power to devices when the main power source fails, preventing data loss and hardware damage. There are different types of UPS systems, including standby, line interactive, and online UPS, each offering varying levels of protection, from basic power outage coverage to full regulation of power quality. UPS devices are commonly used for servers, workstations, networking equipment, and other critical devices that require consistent and stable power for operation. A UPS offers peace of mind by ensuring equipment is protected from unexpected power interruptions and provides users with time to save data or shut down systems safely. Universal Serial Bus, or USB, is a widely used industry standard for connecting computers and peripheral devices such as keyboards, mice, printers, and external storage devices. USB allows for data transfer and power supply between devices, offering high-speed data transmission and the ability to charge or power devices through the same connection. USB has evolved over time, with common versions including USB 1.1, USB 2.0, USB 3.0 and 3.1, and USB 4, each providing faster data transfer rates and improved functionality. USB connectors come in different shapes and sizes, such as USB-A, USB-B, USB-C, and micro USB, with USB-C being the latest, offering a reversible design and faster data transfer. USB is used in a wide range of applications, from connecting peripheral devices and charging mobile phones to transferring large amounts of data between devices like computers and external hard drives. Unified Threat Management, or UTM, is an integrated security solution that combines multiple security features such as firewall, antivirus, intrusion detection prevention, and VPN into a single platform. UTM devices centralize network security by providing all-in-one protection, making it easier to manage and monitor various aspects of network security in a single interface. Common features of UTM systems include content filtering, email security, data loss prevention, and web application security, offering a comprehensive approach to threat defense. UTM is commonly used in small and medium-sized businesses and enterprises to protect against a wide range of cyber threats and ensure secure network communication. UTM solutions simplify security management, reduce the complexity of deploying multiple security appliances, and provide a cost-effective way to secure networks against evolving threats. Vulnerability assessment, or VA, is the process of identifying, evaluating, and prioritizing security vulnerabilities in a system or network to mitigate potential risks. VA tools and techniques scan systems for known vulnerabilities, such as unpatched software, misconfigurations, or weak passwords, and provide reports on the security weaknesses that need attention. VA can be conducted through automated tools, manual testing, or a combination of both. Common types of assessments include network vulnerability scanning, web application testing, and penetration testing. Regular vulnerability assessments help organizations detect and address security gaps before they're exploited by attackers, ensuring better protection of sensitive data and systems. VA is essential in various industries, including IT, finance, and healthcare, to comply with regulations, ensure secure system configurations, and reduce the risk of cyber attacks. Virtual Desktop Infrastructure, or VDI, is a technology that allows users to access virtualized desktop environments hosted on a central server rather than running directly on local devices. VDI uses hypervisor-based virtualization to deliver a complete desktop experience to end users, enabling them to run applications, store files, and access resources remotely from any device. VDI centralizes desktop management, improves security, and reduces IT overhead by allowing easy updates, backups, and maintenance of virtual desktops instead of individual physical machines. VDI is widely used in enterprise environments for remote work, disaster recovery, and managing large numbers of desktops efficiently in industries like healthcare, education, and finance. While VDI improves flexibility and centralization, it requires sufficient server resources and a reliable network to provide a smooth user experience, especially for resource-intensive applications. Video Graphics Array, or VGA, is a standard display interface used to connect monitors and graphics cards to computers, offering a resolution of up to 640 by 480 pixels with 16 colors. VGA was developed by IBM in 1987 and was widely adopted for computer displays, providing an analog signal to drive CRT monitors and early LCD displays. While VGA was once the standard, it has been largely replaced by digital interfaces like HDMI, DisplayPort, and DVI, which offer higher resolutions and better image quality. VGA is still used in legacy systems, projectors, and some older monitors, though it's becoming less common in modern computing setups due to its lower resolution and analog nature. VGA's analog signal can result in signal degradation over long cable lengths, and it lacks support for high-definition resolutions and digital features like audio transmission. A virtual local area network, or VLAN, is a logical grouping of devices within a network designed to segment and organize network traffic, regardless of physical location, enhancing security and performance. VLANs allow network administrators to partition a single physical network into multiple logical subnets, improving traffic management, reducing broadcast domains, and providing more granular control over network traffic. VLANs improve network security by isolating sensitive data traffic, optimize network performance by limiting congestion in specific segments, and simplify network management through logical grouping of devices. VLANs are commonly used in enterprise environments to separate departments, user groups, or services, for example, separating finance and HR traffic while maintaining a single physical network infrastructure. VLANs are configured using network switches and routers, and each VLAN is typically assigned a unique ID or VLAN ID, allowing traffic from different VLANs to be managed independently. Virtual Network Computing, or VNC, is a remote desktop sharing protocol that allows users to view and control another computer's desktop over a network. VNC operates by transmitting the keyboard and mouse events from the client device to the remote machine and sending the screen updates back to the client device, enabling remote control and access to a desktop environment. VNC is platform independent, meaning it can be used across different operating systems such as Windows, Mac OS, and Linux, making it versatile for remote access to diverse systems. VNC is widely used for remote troubleshooting, system administration, and accessing systems in environments where physical access is limited or impractical. VNC is typically used with secure tunneling protocols like SSH or VPNs to encrypt the communication, as the standard VNC protocol itself lacks strong built-in security features. Voice over Internet Protocol, or VoIP, is a technology that enables voice communication and multimedia sessions over the internet or other IP-based networks instead of traditional telephone lines. VoIP converts analog voice signals into digital data packets and transmits them over the internet, enabling cost-effective communication between users on different networks. VoIP offers significant cost savings, especially for long-distance calls, and provides additional features such as video calling, voicemail, and conference calling, often bundled into the service. VoIP requires a stable internet connection with sufficient bandwidth to maintain call quality and can be implemented using various devices such as IP phones, soft phones, or mobile apps. VoIP is commonly used in businesses for internal communication, remote work solutions, and customer support systems, as well as in residential services for affordable voice calling. A virtual private network, or VPN, is a secure connection method that allows users to send and receive data over a public network, such as the internet, while maintaining privacy and security. VPNs encrypt data traffic, creating a private tunnel between the user's device and the internet, protecting sensitive information from eavesdropping and unauthorized access. There are various VPN protocols, including OpenVPN, IPsec, L2TP, and PPTP, each offering different levels of security, performance, and compatibility with network infrastructure. VPNs are commonly used by remote workers to securely access corporate networks, by individuals to protect privacy while browsing the internet, and by organizations to secure communications and prevent data breaches. VPNs enhance online security, provide anonymity by masking the user's IP address, and enable access to region-restricted content by routing traffic through different locations. Video Random Access Memory, or VRAM, is a specialized type of memory used by graphics processing units, or GPUs, to store image data and frame buffers, enabling faster rendering of graphics and video. VRAM holds textures, video frames, and other graphical data to ensure smooth and efficient rendering in applications such as gaming, video editing, and 3D rendering. There are different types of VRAM, including GDDR, or Graphics Double Data Rate, and HBM, or High Bandwidth Memory, with GDDR5 and GDDR6 being commonly used in modern graphics cards. The amount and speed of VRAM directly impact a GPU's ability to handle high-resolution textures, multiple monitors, and demanding tasks like 4K gaming or professional graphics work. VRAM is critical for gaming, video production, CAD applications, and other graphically intensive tasks as it enables faster processing and rendering of complex visual data. A Wide Area Network, or WAN, is a telecommunications network that spans a large geographic area, such as cities, countries, or even continents, connecting multiple local area networks together. WANs use various technologies such as leased lines, satellite links, and public internet connections to facilitate communication and data exchange over long distances between offices, data centers, and remote locations. WANs are commonly used by businesses and organizations to connect branch offices, remote workers, and data centers, enabling centralized communication, resource sharing, and cloud access. There are different types of WANs, including private WANs, operated by an organization, and public WANs, such as the internet, each serving distinct purposes for connecting distant networks. WANs provide businesses with the ability to collaborate across geographically dispersed locations, access centralized applications, and ensure data availability, promoting operational efficiency and flexibility. A wireless access point, or WAP, is a network device that allows wireless devices to connect to a wired network using Wi-Fi or other wireless communication standards. Wireless access points serve as bridges between a wired network and wireless devices, transmitting data via radio waves and enabling mobile devices like smartphones, laptops, and tablets to access network resources. Wireless access points can be standalone devices or integrated into wireless routers, providing various levels of coverage, security, and bandwidth depending on the model and configuration. WAPs typically include security protocols like WPA2 or WPA3 to protect wireless networks from unauthorized access and ensure encrypted communication. WAPs are widely used in home networks, businesses, schools, and public places, providing seamless Wi-Fi access to employees, customers, and guests. Windows Remote Management, or WinRM, is a Microsoft protocol that allows remote management of Windows-based systems, enabling administrators to run commands, manage settings, and troubleshoot systems remotely. WinRM uses the WS Management Protocol to facilitate secure remote command execution and management, allowing IT professionals to administer servers and computers without physical access. WinRM supports encrypted communication, ensuring secure data transmission over the network. It also uses authentication methods such as Kerberos and NTLM for secure access. WinRM is commonly used in enterprise environments for system administration, automation of tasks, and integration with management tools like PowerShell and System Center. WinRM must be enabled on both the local and remote systems, and it can be configured using group policy or via the command line to allow specific management features and access. A wireless internet service provider, or WISP, is a company that provides internet access to customers using wireless technology, often in areas where traditional wired connections like DSL or fiber are not available. WISPs use wireless towers or access points to transmit data to customers receiving equipment, which is typically installed on the customer's premises, such as a Wi-Fi router or a fixed wireless antenna. WISPs provide high-speed internet in rural and remote areas where laying cables for broadband might be impractical or cost-prohibitive, offering an alternative to traditional ISPs. WISPs often use technologies like Wi-Fi, microwave, or point-to-point radio links to connect users to the internet, providing different levels of service based on local infrastructure. WISPs are commonly used in rural areas, small towns, and places where traditional wired broadband providers have limited coverage, making the internet accessible to underserved communities. A wireless local area network, or WLAN, is a type of local area network that uses wireless communication, typically Wi-Fi, to connect devices such as computers, smartphones, and printers within a limited geographic area. WLANs allow devices to communicate and share resources over a wireless connection, eliminating the need for physical cabling and offering greater mobility and flexibility in device placement. Key components of a WLAN include wireless access points, wireless adapters, and routers, which work together to manage the network and provide internet or intranet access to connected devices. WLANs are secured through encryption protocols like WPA2 or WPA3, which protect the data transmitted over the network from unauthorized access and interference. WLANs are widely used in home environments, businesses, educational institutions, and public spaces to provide wireless internet access and enable easy communication between devices. Wi-Fi Protected Access, or WPA, is a security protocol designed to secure wireless networks by encrypting data and preventing unauthorized access. WPA improves upon the older WEP, or Wired Equivalent Privacy Protocol, by providing stronger encryption and dynamic key management using technologies like Temporal Key Integrity Protocol, or TKIP. WPA has evolved in two main versions, WPA1, which uses TKIP, and WPA2, which uses the more secure Advanced Encryption Standard, or AES. WPA3 is the latest version, offering even stronger encryption and enhanced protection for public networks. WPA provides encryption, user authentication, and data integrity, helping to protect against attacks such as eavesdropping, man-in-the-middle, and replay attacks. WPA is commonly used in home and enterprise wireless networks to ensure secure communication, particularly in environments where sensitive data is transferred over Wi-Fi. A wireless wide area network, or WWAN, is a type of network that provides wireless internet and data communication over a large geographical area, often using cellular technologies such as 4G, 5G, or older 3G networks. WWAN allows mobile devices such as smartphones, tablets, and laptops to connect to the internet and access network resources over vast distances, even in remote or rural areas where traditional wired connections may not be available. WWAN utilizes various cellular technologies like long-term evolution, or LTE, and 5G to offer fast data speeds and reliable connectivity, supporting everything from basic browsing to high-bandwidth applications like video streaming. WWAN is commonly used in mobile devices, IoT applications, remote work solutions, and backup internet connectivity for businesses that need reliable, widespread coverage. WWAN provides flexibility and mobility, allowing users to access the internet and data services from almost anywhere, whether on the move or in areas without wired broadband access. Extended Detection and Response, or XDR, is a comprehensive cybersecurity solution that integrates multiple security tools and data sources to detect, investigate, and respond to threats across an organization's entire network infrastructure. XDR aggregates data from endpoints, networks, and servers to provide a unified view of security events, allowing for more effective detection and quicker response to advanced threats such as malware, ransomware, and insider attacks. XDR solutions typically include endpoint detection, network traffic analysis, and cloud security, all working together to enhance threat visibility, provide automated responses, and reduce the time required to mitigate attacks. XDR improves the efficiency of security operations by automating threat detection and response, reducing the need for manual intervention, and helping security teams focus on high-priority incidents. XDR is used in enterprise environments, particularly in industries where cybersecurity is critical, such as finance, healthcare, and government, to protect against sophisticated multi-layered cyber threats. XFS is a high-performance journaling file system developed by Silicon Graphics, or SGI, for use in Unix and Linux-based operating systems designed to handle large amounts of data and provide excellent scalability. XFS supports large file sizes, high-performance I/O, and fast recovery after a system crash, ensuring that data integrity is maintained even in the event of power failures or system errors. XFS includes advanced features such as metadata journaling, dynamic inode allocation, and support for very large files and file systems, making it suitable for high-capacity storage environments. XFS is commonly used in enterprise servers, high-performance computing environments, and applications that require robust storage solutions such as database servers, media storage, and scientific computing. XFS offers superior performance in handling large amounts of data, fast file system recovery, and efficient management of disk space, especially in environments with heavy data usage. Cross-site scripting, or XSS, is a security vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users, potentially compromising their data or session. There are three main types of XSS: stored XSS, where malicious scripts are stored on the server; reflected XSS, where scripts are reflected from the web server; and DOM-based XSS, where the client-side code manipulates the DOM. XSS attacks typically exploit a web application's failure to properly sanitize input data, allowing attackers to inject scripts that are executed in a user's browser when they visit a compromised page. XSS can lead to a variety of attacks, including session hijacking, stealing sensitive information, redirecting users to malicious websites, or spreading malware. Mitigating XSS vulnerabilities involves input validation, output encoding, and implementing security measures like Content Security Policy, or CSP, and sanitizing user inputs to prevent malicious scripts from being executed. Be sure to check out the rest of the study materials on the channel, and good luck on your exam and success in the IT industry.